PPA Assignment 7 I know will have been a struggle for lots of you. This is the hardest assignment we're going to set this semester. Kind of like the last few questions in an exam, which are designed to stretch and push you. That's what Assignment 7 was supposed to do. So we appreciate that you've got other stuff going on, so we'll try and reflect this in the marking that we perform. But hopefully you're able to give it a good go. And of course, it's good to be stretched, it's good to work hard, it's good to find things difficult at times, because if things are difficult, then it usually means that we're learning in that way. So Assignment 7, very much designed to push you that little bit further. There's always one assignment a semester that we aim to format in that way. And of course, perhaps those of you who found the other ones trivial were stretched a little bit more than usual during this one. Okay, so again, well done as always for all your hard work, and we promise that this continuous assessment structure will pay dividends in the end, especially when we get to next semester and you're hopefully therefore more comfortable with certain things than you would have been had you not had this continuous approach to the material. Yeah, so no intention here to torture you with continuous assessment in any way. We're only doing it for you. We're only giving you the minimum work that we think we can give you, while still adequately preparing you for next semester, and of course preparing you for the final exam, and of course the world when you become programmers yourselves. Again, if you're concerned or annoyed in any way, or kind of have issues with the structure here at all, please talk to us so we can reassure you, so we can tell you the plan that we have, and the thought that we've put into everything. And of course, there's so many resources on the forum, on Keats, particularly on the news forum, which tell you these things. So you've probably come to this video because of my email about feedback. Brilliant, I'm glad that you're here to watch. I do want to make this point about feedback. So lots of people have been saying, it's unfair that we give you assignments and then you don't get your grades back until a few weeks later after you've already completed some other additional assignments. Now that would be fair if the grades were feedback, but they're not feedback. The feedback that is available to you after you've completed each assignment is available the day after. So I'm talking about this video, and I'm talking about the help and a guidance you get from TAs. Okay, so there's a difference between grades and feedback. If grades were feedback, as I say, that would be terribly unfair to have you to force you to do more assignments without getting anything back on your work. But the grades aren't feedback, or at least they're not new feedback. They're just numbers, and everything that they tell you can already be worked out from the solution videos. So I really want to make a point about this. This is really, as I said, giving me sleepless nights, this idea that people aren't using this feedback that's available. I told you right at the beginning of the semester, that all this was here, all ready for you. So please, please, please use it. Use these solution videos if you haven't already. I really hope it's not too late. It shouldn't be, but please, 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 for my sake, for my sanity, please use these videos to compare your work to what I've done here, and don't go blindly into the next assessment without seeing these videos. So yeah, if you've not seen any of these yet, please go back and look through them. And of course, you might think, well, this is just generic feedback. It is, but of course then also you have the conversation with your TA, who will give you personalized feedback. But also, as you'll see today, I'm going to discuss loads of different permutations on the solution, so you can see different things people did. So while it is generic feedback in some sense, it is also tailored to you guys, so you can learn things in this way. All right, so use these videos. Please use them if you haven't already. Much of university is about not waiting to be told that you're doing something wrong, but also proactively seeking this advice. But again, I know you're only still you're all still learning kind of the way things are. So of course, that's why these assignments have such a low weighting, because they're more to learn both about programming and procedure rather than really to be assessed. Okay, so that's another general point. As long as you can complete as much of the assignments as you can. So for example, PPA assignment 7, hopefully you complete as much as you could. That's fine, and it won't have a huge impact on you. Okay, so please access these resources. I can't make you sit down and watch them, but even if you can't stand the sound of my voice, please mute them and watch the solution being written. And this is the only real way you can improve. As much as I'd like to actually include this feedback, these videos officially as part of maybe a lecture, or in some way sit you all down and take you through them, I can't. So you have to kind of proactively get this yourself. Don't wait for your grades. This is a distinction that we tried to make very, very clear from the beginning. So there we go. Brilliant. Thank you. I'm glad you're here. All right. So assignment 7, as I say, would have stretched lots of you. This is a good thing. It's good to learn. But of course, no real consequence if you weren't able to do all of it, or if indeed if you didn't, you're only able to do some of it. That's fine. This is all about learning as much as it is assessment. Of course, number 1 rule is just to relax and calmly increment your knowledge as we go through. On a series of islands in the Caribbean, I don't think any of you will ever see pirates in the same way, exists a set of hidden treasure chests buried there by different pirates over many years. Now a new pirate wishes to sail to each of these islands and find any treasure that is buried there. Okay, and so model this scenario based on the following requirements. So the key thing here, as always, break the solution up, approach each section bit by bit, test it as you go, jump ahead if needed to fill out the interface, but leave the content blank, fill out the methods but leave the content blank to try and test things, get things working. And another thing that we really saw in this assignment was just to focus on simplicity, okay? So things might look huge, it might look like there's tons of work to do, but this is still only designed to take you roughly 10 hours, so, spread across a week. So really we're not going to ever ask for huge solutions, so try and keep things simple as possible, try and keep things in context of the notes that you've just seen, and it should be possible to approach these things. And in fact, question 1.1 was a bit of a freebie, so the writing here is quite convoluted. There's lots of talk of gold coins and minting companies and coin numbers, but in the end, all this was testing, as I'm sure you would have got from my hints and tips video, was your ability to kind of use the appropriate information from the notes, which was this blockchain example, where we looked at a block which is actually identical in form to a gold coin. So again, you now might feel hopefully a bit, hopefully you don't feel shortchanged, no pun intended, or kind of that this was a strange question because it's actually asking you for something that already exists in the notes. It's just this idea that we want to push you and test you to understand the different contexts in which we can implement these ideas. Okay, so gold coin, and just to paraphrase 1.1 here, gold coin has a unique number, coin number, so and that should be handled internally by the class, so I shouldn't be able to pass any number to the class, but still when I interact with each coin they should have a new number, a unique number. Okay, so exactly like a block. So if I now go ahead and make my gold coin class, and hang on, so there we go, then you can see this. Okay, so exactly the same principle as we saw for a block. We need this private int coin number, right? So we need to somehow index. Oh, I'm gonna sneeze. Oh, goodness me. There we go. Excuse me. All right. So gold coin here. We want to keep it unique, but we can't pass anything to the class. Okay, so we can't have anything like public gold coin int coin number. Can't do anything like this dot coin number. Yeah, we can't have anything like public void set coin number or anything like that. Has to be handled internally by the class, so there can be no setters even constructed inside this class. That was the rule. So of course this was perhaps at first looked like a bit of a challenge, a bit of a mystery. Hopefully that was kind of something that you pondered on. But then of course, as I say, you would realize that this was exactly like the example that we'd seen in the notes, and of course in the static video, which I think I'm again going to link to from this video, just to kind of re-emphasize its presence there. Okay. So what we could actually see is, again, I didn't want to tell you about needing another field here because this was part of the problem, but we do need another field. Okay, and what this is going to do in exactly the same way as we did with the blocks, and again I think I did it with cars in the static video that's linked, is we have this static field number of coins. Okay, now we know because this is static that the value inside number of coins is going to be the same for all instances. So if I make 3 gold coins and I set number of coins to be equal to 3, then in each of those objects, those gold coin objects, the value in this field is going to be the same. So the process is very simple, again exactly as we've seen in the notes. We're going to do something like this. Okay, so we're going to say I know that inside number of coins it's going to be a fixed value across all instances. So if I increment that value, then it's going to change across all instances. Okay, so all instances are going to track. So obviously what's going to happen here is number of coins. If I make one gold coin, yeah, then the value inside number of coins will be 0, then incremented to 1 as I make my first coin. Then if I make my second coin, this would be incremented to 2, so I'd now have 2 in both my coins. So you can see here, I mean, we can just test this, right? So we can say public int, which is again why I asked you to implement this read coin method, or I said something about how it should be possible to get or read the number stamped onto a coin. So part of the reason I asked you to do this, not again directly related to the functionality of this assignment, but it was to allow you and encourage you to test the value inside gold coin in a straightforward way, so that you'd be able to kind of see that your functionality was working. So again, really, I think you could have used classes like atomic integer, but again, I encourage you not to do this, because generally we shouldn't use classes that aren't at least alluded to from the notes. Wouldn't want really to see you generating random numbers here for the uniqueness, because you can't guarantee that random numbers are unique. So given what you'd been shown in the notes, this was really the only kind of logical way to kind of approach this problem with this combination of static and non-static fields. Okay, that was a little bit of an aside, but what we're doing right now is we're just going to test the value inside number of coins, right? Like this. Okay, and you know that non-static variables can, non-static methods can interact with static fields. We've talked about that because you can reference from the instance to the class, but not vice versa. Again, watch the static video if you need any more clarification of that. But let's make our main method, our main class. So new, we're going to call it treasure hunt, right? We're going to have a regular main method, which we now know all about and exactly what it does, as we looked in the lecture. And we can make some coins and kind of test this out. So I could say gold coin. This isn't finished, by the way, the uniqueness. I'm just kind of giving you this little segue. Gold coin, could say gold coin. Coin 2 equals new gold coin. Okay. We can say system.out.println coin.read coin. Alright. So let's first of all see what happens if we run this. Okay. So you can see 1, right, as I said. So here inside the class, all we're doing at the moment is we're incrementing number of coins. So originally it's 0, of course, because that's the default value inside this field, but then we increment it to 1. So that happens upon object construction, so the resulting value there inside number of coins is 1. So if we print out what's in there inside when we read coin, we get this 1. All right, so then if I do it again here for coin 2, then it's going to say 1, 2, right? Which fairly normal, right? We increment it again inside here, so that makes sense. But of course, there is a subtlety here, of course, because when I've made coin 2, right, if this wasn't static, then this would go back to being just 1 and 1, right? See? So 1 and 1, because they now have separate copies of number of coins, wouldn't they? Coin would have one copy of number of coins, and coin 2 would have a different copy of number of coins. But of course, because it's static, then coin 2 starts off with the number of coins that were assigned in the first coin, because this is a shared field among the class. Any changes to it made inside one object affects all the objects, and we confirm that by again saying system.out.println coin1, coin.read coin, and you can see whereas previously this was 1, this is the first print statement here, then it's 2 because I'm looking inside coin 2, which I guess makes sense so far because we've grabbed that value that was set by the first coin. But then of course if I go back to my original coin, then the value inside there has changed. Okay, it's now 2, despite the fact that I've not actually interacted with coin again. This is just me making coin 2. The value inside coin, the first coin, has changed as well, which confirms that these objects are sharing the same values in this static field. Okay, so that was again just a nice thing to do straight away. Try and test things as early as possible, just see what's going on. So the only thing to do now is we can capitalize on this idea that effectively number of coins is always going to track the number of instances that we have. So we can effectively, what we do is we take a snapshot here of what's inside this field at the time. So of course there's no link here. Just because this is updated doesn't mean that this is going to update as well, just because of the equals. Remember, we take this idea of getting a value rather than a reference. So we get this value from number of coins. So then when we update number of coins in the future, coin number will stay the same. Okay, so then rather than reading coin from number of coins, we're actually going to just read the coin number. All right, so while this changes and increments with the number of instances, coin number here will remain to be a fixed snapshot of the number of coins. So again, I'm not going to say too much about that because this is all in the other video. I explain this in lots of depth, except it's in relation to cars. Exactly the same code, just different variable and method names, or field and method names. Okay, so this allows us to get our unique coin, and again, I guess we could just, for the sake of it, test it out. So lots of the things in that I'm going to show you here are use this kind of idea of not declaring a class in the full way that we've seen. So we've seen gold coin, coin equals new gold coin like this, right? So this should be familiar. So what we understand so far is that we make this class copy, we store it inside this empty variable of a class type, and then this becomes the object, right? That's our current understanding. Again, as I keep saying, what's really going on is a bit more subtle in memory, and this will be explained to you at the beginning of next semester. But this understanding that this is the object is sufficient, mostly, for you to understand what's going on in Java. Okay, which is why it's okay to give you this higher level understanding. But of course, because this is the class copy, this means it has everything that the object will have, right? So if I do new gold coin here, this is just then a copy that's going to be stored inside this variable such that it becomes an object. So I can actually interact directly with this class copy before it effectively becomes an object. But of course it is the object, as you'll see next semester. Spoilers. So here you see I can do, or I can interact with all the methods that are actually inside gold coin, right? I can do read coin straight away. So this is a subtlety. So again, you can get away with not doing it in this way. You can almost always get away with just assigning things to variables, or assigning class copies to variables and then interacting through the variable. But sometimes it makes things neater and simpler just to interact with the copy directly, or again, as we'll see next semester, actually as the object. Okay, so just to test that, I can do that here. So if I do system.out.println new gold coin in this like this, and I print this, it will give me 0, of course. Why is it 0 and not 1? Well, because we assign the value inside coins to coin number before incrementing it. So the value inside number of coins in the first instance of gold coin is 0. So we assign 0 over here and then increment it afterwards. Okay, so that's the setup that we've got there. So this will be equal to 0, and then if I make another gold coin, this will be equal to 1. And we can see, therefore, because we're incrementing it in this way for all instances, it can never be the case that a coin is not, or is not given this unique number. Okay, so there you go. That's exactly how you do uniqueness. Nothing with atomic integers or random numbers or anything like that. Just simply using what we'd seen already in the assignment. In the lecture notes. So there we go. Again, read coin, not directly related to the functionality of the class, just put there to kind of help you and give you a way to understand or prompt you to kind of test your coin as early as possible. And of course, there's this line that says that although not directly useful to the pirate, this information may be important to other individuals who interact with the coins. Okay, so just a little hint there that this isn't actually going to be used, this read coin, but it's just there for you to use and to prompt you to test your classes as early as possible. Next, model a treasure chest. A treasure chest consists of a set of gold coins. Okay, so it's nice and important to always approach these the bits of these assignments in a kind of sequential way as possible. Always keeping things simple. Again, part of the challenge of this assignment was just to keep things as simple as possible. Always do things in the context of what we've learned in the lecture. Okay, so I asked for a treasure chest, and it consists of a set of gold coins. Okay, so I know I want a set of coins. We looked at this example, I think, at least in the hints and tips. I looked at this idea of an aeroplane in a hangar, and I could have said something like aeroplane 1. I could have made my hangar class and done things like aeroplane 1, 2, 3, 4, 5, etc. But because these are all the same type, then we know that we can slim things down by using an array, right? So we can approach this idea that a class would just contain multiple fields of the same type by using an array. So something like gold coin, coin 1, etc. Gold coin, coin 2. Obviously, because in my brief at least, I'm asked to store 18 gold coins. This would be quite cumbersome to have to write them all out. So instead we collect them as recommended in the notes. We collect them as an array, and of course we declare an array. We say that we want to store a set of things rather than just a single thing by using these square brackets. Always private, so generally everything that's outside of your class, remember, if it's an array, if it's going to be ultimately hold an object, if it's going to be a variable of a class type, if it's going to be a variable of a primitive type, always private. So lots of things I see people doing, I've talked about this before in much earlier videos, always keep these things private, whether they're, no matter what type they are, try and keep these things private outside the class. Okay, so I'm going to give this a name, obviously, coins. And again, something subtle, I don't really like to see the actual assignment of the array on the field itself. There are a couple of reasons for this. Had a really good discussion about this over email before. The reason for this is I've seen people doing lots of different things outside their method. So maybe using the random class, which again I'll say in a second would have been fine for this assignment. I've seen people, declaring, things like random and then using the result of creating these random numbers in fields with other fields, of course. And we know that in general the order of fields doesn't matter and the order of fields doesn't matter, but what does happen inside the methods does matter. So I think it's not a bad thing. I think it's an easy trap to fall into. It's thinking that you can define these fields outside your class in any order and then reference them. So as I say, people might have declared kind of the random class here, random, or etc. etc. Again, this isn't real code, and then here they might have somehow used random.nextInt, right? Something like that, maybe to select something in that way, or to add something into the array in a position. Okay, obviously this wouldn't work. Again, it's just conceptual. So because you're declaring the random class after you have your array, and then or after you've tried to access the object for the array, so they're in the wrong order, and it's a lot more difficult to see this when they're as fields, whereas it's much more evident when they're inside the constructor or a method itself. Okay, and again, that's because we have this general rule that the fields don't matter, except in circumstances when the fields rely on each other, in which case the order does matter, and is a bit more obscure about what's being initialized in what order. So again, to avoid this, and there are a couple of other reasons for not assigning things directly on fields. First of all, I think it's a lot easier to make mistakes. So again, I saw solutions where people would do new gold coin here and then do new gold coin again in the constructor, which again is an easy mistake to fall into, because when you assign things on fields, you're much more likely to then want to assign them again, out of habit inside a method. So if you just always go by the rule of thumb that we avoid assigning things on fields, then it's a lot better. And of course, personally for me, it just looks a bit more readable. So this is a good example of a style choice, right? I would never mark you down, or I mean, it's best not to talk in terms of marks, but I would never kind of criticize your code directly anyway, kind of formally. Maybe I would unofficially, kind of just giving you advice on style, but I would never formally criticize your work if you chose to do that, right? Because it's an element of style. So I know lots of people are having concerns about this notion of style. So I said very early on in the course that you're free to adopt your own style, but that didn't mean, and this applies to things like this. So assigning values on fields, how the exact choices you make in terms of how many spaces and tabs you use, or whether you choose between them, where you put your curly brackets, things like this. These are all components of your style. Style is not the ability, as I said in the email that you hopefully came from to see this video. Style is not the ability just to do, approach the assignment in your own way whilst completely ignoring the rules and conventions and the notion of efficiency, right? So yes, you're encouraged to, approach the assignments in a way that's natural to you. We are open to alternative solutions, maybe not at first from the automatic marker, but of course that's why we have this grade query system. We are open to alternate solutions, but they must of course still be efficient. They mustn't flout the rules of programming that we've taught you. Okay, so I've seen a couple of grade queries where students have said, I thought you were open to alternate solutions, why am I being marked down here? First of all, of course, as I've said, the automatic marker is maybe a bit stricter in that respect, but also really look at your solution. So I've seen a couple of solutions where students have claimed, this is my approach, this is my way, but I've seen that they've by kind of following that approach, they've introduced inefficiencies and they've kind of gone against convention. Okay, so just look really carefully there at why that might be. And of course, yes, we are definitely open to your own style, which of course is really just aesthetic things, visual things, almost all the time. They don't affect the behavior, that's a key thing, and they don't affect efficiency. Okay, so as I said in my email, I'm a little concerned that this has been misinterpreted. Yes, we're open to these these style choices. And of course, we're open to alternative and creative solutions. They should not compromise functionality, behavior, or efficiency. So of course, the easiest thing to do is to just follow the style that we've taught you to ensure these things. But of course, if you want to deviate, you can, but just be aware that there are these restrictions. Okay, so again, a little bit of an aside there, but hopefully helpful and informative for you. Okay, so what I want to do when I declare my coins is I don't want to do it on the field itself. I want to do it inside a constructor. Okay, so what we pass here, if anything, we'll talk about in a second. But at least for now, we want to declare, you know, that we want to initialize this array. And of course, because arrays are a special form of object, the way we assign and declare an array is very similar. So we'd say new as well, and we'd say gold coin here as such. And then we put a value inside the square brackets here, just to indicate the number of coins that we're going to store in our chest. Again, okay, so this is the familiar form of an array. This is what was shown in the notes. So I saw a couple of people getting these null pointer exceptions because they were trying to access an index in their coins or whatever array they were using, array without first using new. Okay, remember this is exactly the same as the error that I showed you a few weeks ago, kind of discussed, I think, in the lecture, or at least in the video. We talked about this idea of trying to access fields of a class type before actually putting values in those fields. This would be the same process here. So if I were going to try and later on say something like coins 1 equals something, that would give me an error, right? And I actually think no, it would be a runtime error. So it would compile fine. Of course, Java, remember we talked about what the compiler does and doesn't do and what it necessarily can and can't do, because to keep things efficient and because of this uncertainty when you're actually running things. This wouldn't be caught at compile time, but if you run it, then actually let's test it. As always, let's just try and test it. So if I now say treasure chest, my chest equals, oh, that's a very poor choice of words. Let's call it treasure chest equals new treasure chest. And let's see what happens. So if we run this now, of course, here I get this null pointer exception, right, which I'm sure many of you will have come across. So to avoid this, of course, you need to put, you need to actually initialize your array. You need to effectively, I mean, it's a bit more abstract than that, but you need to put an array object inside this field of an array type. Okay, you need to actually initialize this. And if you don't, as you would with any object, you get this idea of a null pointer exception. But of course, you need to say how big the array is, which is a limitation, of course, of arrays, which this assignment was effectively designed to take you through and test. It might have been frustrating at times, but that's important for it to be frustrating because it has to motivate the need for these other data structures like array lists, which of course you're now permitted to use from now on. And if you wanted to, you could except perhaps if prompted, or if it's clear from that you want something of a fixed size. Okay, let me say again. So you could use arrays from now on instead of array lists from now on instead of arrays, unless it's clear and it's prompted that you use a fixed size. In which case, obviously, you're going to need an array in this respect, or to find some class, some data structure that allows you to create this fixed size. But just to keep things simple, if you're told to create a fixed size, then I would do so. And of course, and again, I stole this idea from Thomas. I was chatting to him about this. This is a great idea. Another place in which it's nice to use arrays is when you, of course, again, as a connected point, you know the fixed size that you want, right? So for noughts and crosses, I think it's a lot cleaner, a lot neater to use an array because you know it's 3 by 3, right? So it makes sense to use an array there. But again, generally, if you find that arrays are awkward, you want to do lots of taking out and adding in, like we did in this assignment, then array lists are fine. Instead. Okay, so I know my chest can hold 18 gold coins, so of course I have to supply this fixed size inside there. So that's the general form of declaring an array with this certain size. Now it says there's another important line here, so it says that the treasure chest can hold 18 coins. Oh, if you heard a voice in the background, then that was my Alexa, by the way, who thought I was talking to her. No, I'm not talking to you. I don't think I said Alexa. Anyway, I'm not sponsored by Amazon or anything. So a treasure chest can hold 18 coins, a value that is fixed for all chests. This is an important point, right? So it's fixed for all chests. Again, watch the static video. But the point here was to draw you towards, at this point, that we want this public static final field, which is going to communicate to us the number of coins. Okay, so we can say coins in chest, or something like that. Now again, we know to use this because it's said in the brief that this is a property of the class, so we know that all chests are going to have the same number of coins in the same way that we looked at this dog example in the lecture. All dogs have the same number of legs. And again, in this supplementary static video, which is again linked to from this video, we saw this idea of cars all having the same number of wheels, so we made this public static final as well. Okay, exactly the same principle here. We make it 18, and then we can actually reference this just to avoid repetition and to keep things consistent. We can reference this directly when we make the size of our coins array. Just to plug another video, so there was a good discussion on the forum, as there always are. This is fantastic engagement on the forum, like I've never seen before. Absolutely fantastic. People were asking, can I make this final? You could, and again, this is a style choice, not something I'd mark you down on. But I actually made a video explaining why I think final and private are an awkward combination. To summarize, it's because if things are final like this, then it feels more natural for them to be public. And of course, once things become public and they're not also static and final, people are much more likely to build to your internal state, which is not something that you want. Again, I'll link you to that video in case that's of interest too. And again, this is something that will be reinforced next term when you look at encapsulation again and think about, what's this notion of people relying on your state and how does that reduce the freedom you have to change the internal representation of your classes. So I've left that non-final. I generally don't tend to make things final in this way. Of course, just style again. Wouldn't mark you down for that for you using final here if that felt natural to you. Again, final, the utility of making these things final is reduced because of course it's private inside the class. So that's yet another reason that I think it's perhaps not necessary or a little awkward to keep things final. Of course, in terms of maintainability, if this is final, then people are much less likely to come and edit your class and try and assign things to it unnecessarily. Okay. But of course, we do keep this final, again, for the reason that if things are static, they typically are also final. So we can represent that this is true of all chests having the same property, regardless. And again, I mean, taking that same argument forward, if this is final, it kind of suggests that all coins have the same number, which is again a little conceptually awkward because they actually all have different numbers. So again, and that's yet another reason to omit final here. But we know that all chests have 18 coins in them, so it makes sense for it to be final. If it's final, it makes sense for it to be static, so we can access it quickly and efficiently just by writing the name of the class. And which I guess really we should do here. We should write treasure chest. Got coins in chest, and you will actually find circumstances where Java warns you if you don't do that because it's slightly less efficient, but I'll leave that for now. And if it's static and final, it can be public too because there's no danger of compromising encapsulation with it being final. Again, all these reasons reinforced in this static video that I made last time and has already had a good number of views, which is great to see. So that's how we'd do this. We'd represent the fact that this is fixed for all chests. So we've now got this empty. This is a very key point. This is an empty gold coin array. Again, I saw lots of people assuming this would be filled with gold coin objects. It's not. So unlike primitive arrays which are filled with, say, zeros or Boolean arrays that are filled with, false, it's not true of kind of class type arrays. These are empty to begin with, just full of nulls, which is actually an important thing that we'll capitalize on in a minute. So of course there'll be another step we have to do in a second in order to fill this chest with gold coins. Okay, so again, another mistake I saw people were doing, they were saying, I can't take items out of my chest and put them in my purse. And I saw lots of people who hadn't actually gone through and put these objects into their kind of chest, their treasure chest directly. And of course this now leads on to the next point of the brief if you're following. So when a chest is first made, it's filled with the maximum number of gold coins it can contain. Okay, so this is telling me that I have to, inside my constructor, do some kind of loop to fill my chest with coins. Okay, so I'm going to keep this as simple as possible. As always, there are probably refinements you can make to this, but I just want to always go for the most intuitive solution. So I'm going to use coins.length here just to re-emphasize how you have this loop that goes through a full array, which is what we want to do here. I could even call this coin, maybe something like that, just to keep things clear and readable. I isn't always the most readable. Again, style choice. So here we can say coins, coin, okay, equals new coin. I'll take a new gold coin. I'll take a step back in a second. So remember, again, another issue I saw people having is kind of trying to access elements that are outside the length of an array. Very important errors to come up against and subsequently solve. Again, yet another really important feature of this continuous assessment structure. Allows you to engage with issues early so that they're not a really big issue on you in the future and really build up your experience in the most suitable way. So you'll have experienced, I guess, if you try to do things like less than or equal to, you'd get this index out of bounds exception. Of course, because the last index is always one less than the length of the array, so this length will be 18 slots, there'll be 18 indices here. But of course, because we start counting at 0 and then we're going to end at 17, right? So 0 to 17 is 18 slots. So if we try and do this as less than or equal, and again, let's actually try this out, then we're going to get this index out of bounds exception, right? Because I'm trying to fill the 18th position, because when coin is equal to 18, it's still fine under this loop structure at least. So it needs to be strictly less than, right? And then everything's fine. Okay. Yeah, another issue that I'm sure you'll come across, and it's really important that you face and solve as early on as possible in a programming course like this one. Okay, so when a chest is first made, it's filled with the maximum number of gold coins it can contain. Done. It should be possible to take one gold coin from the chest while there are still coins in the chest, which is then removed from the set of coins in that chest. Okay, lots of people, again, this is quite tricky, but let's look at what's going on here, how we can do this logically. So I know I need a method called take one gold coin. It makes sense for it to return a gold coin, right? Because that's the function of the method. You know, it should be possible to take one gold from the chest while there are still coins in the chest. So, you know, take one gold coin actually suggests that you were going to give some coin back rather than anything else. And of course, it would make sense given what we've built already that you're going to try and interact in some way with the coins array. So it's possible to take one gold coin from the chest while there are still coins in the chest, which is then removed from the set of coins in the chest. Okay, so it should be possible for me to take one gold coin from the chest. So I'm going to need to return some coin from somewhere. Okay, no parameters again. Remember, we're just using this to extract a value from the coins array. No need to pass anything in here. And the fact that we don't have parameters to this method actually suggests that we need some other field. Again, to tell you all the fields that you need would be perhaps to kind of spoil the problem here. There will be a need for a supplementary field here that will allow you to track how many coins there are in your array in the next position that we want to remove a coin from. So we saw this idea in the notes when we were tracking user input, and we had this huge array, this array that was partially filled. We saw this idea that we'd declare a supplementary variable that we would use to reference the next position in which to insert something into the array. And it's a similar principle here. So rather than incrementing this variable, we're going to decrement it, as we'll see in a second. Okay. So what do I mean? So I mean that we've filled this array up now, haven't we? From 0 to 17, it's now full of gold coin objects. So if I want to take a coin from it, it's most logical for me to remove a coin. So for me to return coins, the index that it's most useful for me to start at is coins.length, right? So again, this isn't the final solution, don't freak out. So what this would do is it would take one gold coin from the end of the coins array, wouldn't it? So if I do something like system.out.println treasure chest dot take one gold coin dot read coin. Okay, again, yet another reason why read coin was useful, just for your own testing rather than necessarily for the actual functionality. If I do this now, then I can see that, oh, did I leave my, what did I do? Ah, ha ha ha, excellent. So what have I done here? So I'm trying to access coins.length, right, which is going to be equal to 18, but there is no 18th index, is there? -1, perfect. So again, this is the issue that you probably would have come across. Always remember that if you're working with -1, if you're working with the length, if you're working with the length, it has to be -1. Okay, otherwise you get these problems, right? That makes sense? So coins.length always has to be 1 from it. Otherwise, if you try and access it here, then 18. Okay, it's almost like I didn't do that on purpose. Here we go. 17, right? So the last coin in the array, because remember all coins have this unique index. This is the first treasure chest I've made. So I know that all the coins I've got are listed from 0 to 17. Remember, that's their unique number because of the functionality we did here. So the first coin here in the chest at position 0 will be 0, and effectively in the first chest, the values on the coins will be equivalent to their indices, right? So coin 0, in terms of the value inside coin number, is at index 0, and so on and so forth until 17. So that means, as I say, that the last coin in there is going to have the number 17, so I can see here that I've removed the last coin in the array. Now, how do we extend this? Because of course, if I was to call this twice, what's going to happen? If I were to try and remove the last coin and then remove it again, you see we're going to have this take one gold coin, and actually I'm going to need to set it to null first. That's not going to be an issue. Okay, but let's think about what's going to happen here anyway. So what we're going to do is we're actually going to read the same coin, which isn't really the functionality that we want, is it? Because I want to be able to take one coin, I want to kind of then move backwards through the set of coins and take another one, right? So I want to take the one before. Really, I want this to say 16, not 17. See what I mean? So we want to start at the length of the array and slowly draw or drag the coins out with this coins array from the end to the finish. We could do it from start to end. That would be fine as well. Someone asked this great question on the forum. Does it matter? That would be fine as well. I think it's just perhaps a little bit more conceptually fine to do it from end to beginning. Again, style choice. You know, if you prefer to empty your arrays from the front, who am I to kind of contradict you there? As long as you've got a good reason for that. But of course, I think something that isn't, again, a style choice would actually create bad behavior or incorrect behavior is to take these randomly, right? To take random coins would be bad because you know you could get the same random index twice. Again, so that's a nice example of style versus behavior and whether, and you know, or poor convention or efficiency and where that line falls. All right, so here you can see now if I print it twice, it's saying 17, 17, no errors, which is good, but still not quite the logic that I want, right? I want this to say 16. So what we actually find is we want to slowly take one coin from the array, and to do that, or at least at the moment, at least we're not taking it directly, at least we're just referencing it. What I want to do is I want to kind of declare another counter like this, so private int last coin, yeah, so last coin, and I want to gradually decrease that value as I go back through my array, right? So what I want this last coin to start at is to be equal to 18, so to be equal to the number of coins in the chest. And gradually, every time I take one gold coin, I want to move this pointer. This is effectively a pointer. Again, perhaps poor choice of words for those of you from a C background, but you see what I mean. It's pointing to an index in the array. And every time I take one gold coin, I want to reduce this pointer by 1, right? I want to slowly move backwards and reference something, you know, the next coin going backwards from the chest. So I can imagine I'm emptying the chest from the end to the beginning. Again, similar to what we saw in the lecture notes, except there we saw incrementing this kind of idea of an extra index that's going to allow us to reference this next position in the array, but we're doing it backwards now. But of course, as I said, you could do it forwards as well if you wanted to. So what do I need to do? Well, two things. First of all, I need to set last coin to be equal to coins.length, because we wanted to start at coins.length, as I showed you before. We still want to take the -1, of course. We still want to take the 17th, the 18th, or the coin in position 17 first, so I still want this to be coins.length, but it can't always be coins.length as we've seen, otherwise we'll always try and take the coin in the last position. We want to gradually update the index of the coin that we take. Okay, so last coin minus minus. Makes sense? Good. So what happens now? 17, 16. Brilliant. So I know that last coin is going backwards through my coins, and I'm effectively taking the coins as we go forward here like this, right? So if I do a load of these, 17, 16, 15, 14, 13, okay, so I'm now effectively getting these coin objects out from the treasure chest, which is great. But of course, if we want to simulate removal, which is something that kind of it says here, so it does actually say it's then removed from the set of coins, we could resize the array, which I know some people did. Kudos for doing that, that's fine, but remember I said that's always a bit hacky. So there was this other thing we saw in the notes, which is this notion of null. Okay, and again, part of this assignment was to test your understanding and kind of push you that a little bit further in terms of the versatility of this null identifier. Because of course we've seen null cause errors, but null can actually be useful to us as well. Okay, so what you could do to kind of signify that we were emptying this position in the coins array was to set that position to be equal to null. Okay, so what we'd want to do effectively is we'd want to somewhere say coins last coin equal to null, right? We'd want to do something like this, maybe intuitively. All right. So what this would do is we would index the last coin position here. It's fine. So this, for example, let's imagine the first time around it's 17. So we'd say go to position 17 and set the value inside coins there to be null. So we've effectively emptied it, and then return what's in there, and then decrement afterwards. Okay. I'm sure some of you can see an issue here, null pointer, right? And that makes sense, of course. And again, this is something I showed in the hints and tips video. This whole process of removing stuff was again not only reinforced or hinted at in the lecture notes when showing null, but of course given you that extra push in the hints and tips video. So here the problem is, obviously, if I want to return what's in the position of last coin, I can't first erase it, right? So this is effectively saying erase the coin and then return the coin, which doesn't make sense. I can't erase something before I return it. So the extra step you have to take, or at least the most intuitive step to take, I think, first of all, is to declare this temporary or new variable, so of a class type. So I'll call it something like coin to take. And then what we do here is we kind of save that coin. So we save it inside coin to take. And then what happens is we can freely set the index inside the array to null because we've already kind of taken a snapshot. We've kind of grabbed what's in that array for us to kind of use. Now, of course, we've seen that the rules are different for objects, so there will be some instances in which, especially when you're working with objects, that this will be difficult. So yeah, of course, you're taking an object here out of the array, but there will be some times when linking things together in this way won't have the desired effect. Again, when we look at objects in memory next semester, that will become clearer. But for now, it's fine to kind of take this snapshot of what's inside the coins array. Again, what you're taking is more subtle. It's actually a reference. Spoilers again for next semester, but see what's going on there. You'll see what's going on there next semester. But again, for now, it's fine for us to kind of take this snapshot of what's inside the array. We're kind of taking a copy of the object that's inside there, because of course we know we filled our coins array with these objects. So we take this snapshot of the object, we save it, and then we can set where it was, or so there's now effectively two of them, isn't there? So I've got one copy inside last coin, and then this, the same copy inside coin to take. Again, this will become clearer next semester, but for now, hopefully that understanding is intuitive. So now when I set the second copy to null, I've still got this saved copy for me. All right, so what I then don't want to return is obviously last coin. I just want to actually forget about the array altogether. It's no longer of use to me because that position is now null. So I actually instead just return coin to take. Okay, that makes sense, and everything's fine. And now what we can do, and here's a nice tip if you're working with arrays, is to use the arrays class, which I actually told you about before. So I think it's java.util.arrays. So I showed you this briefly in the lecture. And I showed you, of course, that arrays has this nice toString method, which allows you to visualize what's actually going on inside your array, which is nice. Again, that was in the notes, so you could have used this to help you out in terms of your debugging. And if we run this now, obviously, sorry, I need to put that in a always forget this. I need to put that in a print statement because it just returns a string which needs to be printed. I can then actually have a look at what's going on inside my coins array, right? So first of all, it's full, and you can see now, look, it's gradually being made null. You see what's going on here? So again, we now know actually that this is something to do with the object's memory address and its class name. But here you can see that we're gradually emptying this array. That makes sense. So again, a nice thing to do is to use arrays.toString to understand exactly what's going on in your arrays, and you can see here that we're nicely emptying this array. But of course, we only want to do this while, a nice extra little check to put in here is to make sure that no one can keep taking coins while they're not there. I'm not sure if this was explicitly mentioned from the assignment. Obviously, if it wasn't, then there's no marks associated with this, but just nice to keep your code consistent. So we'd actually want to say that we only allow this process to continue if it's the case that last coin is greater than -1, right? Because otherwise, let's look what happens. So if I happen to do this 17 times, actually let's just do a little trick here. So the old while true loop. Let's see what's going on here. So if we try and keep taking coins, let's imagine we keep doing it forever, then eventually we're going to run into trouble, right? Because you see, -1. And again, this is something you guys would have seen, I'm sure. You would have seen, maybe you hadn't quite, as we'll look at in a second, got your get treasure array right. Sorry, your get treasure loop right, and you were maybe then trying to take too many coins and you'd end up with this -1. Okay, so what we want is some check that that people aren't only trying to take or only able to take coins while there are still coins there, right? So again, we looked at this in the context of increasing an index in the lecture notes, but now we're looking at decreasing an index. So it's just about taking that knowledge and applying it to a new circumstance. To actually say if last coin is greater than or equal to 0, so obviously that's the last possible index we can allow people to take from, then we just return that. Otherwise, we go ahead and we return null. Okay, so this would obviously result in a null pointer, but it's much better than trying to access the index out of bounds. Okay, see here I've got this null pointer because I was trying to keep accessing, but that's better. It's clearer what's going on there. It's clear that our code is protected. See what I mean? So we've kind of shifted the issue here to the user, which would be treasure hunt, than us. So before, when we weren't protecting our array in this way, so let's take this out and look again at the error message. When we're not protecting our array in this way from people that can keep taking stuff from it, you can see that the error now falls under our remit. So remember, our remit is the class, the user's remit is the main method. So this is just the method that we use typically, except we've kind of stretched the definition a little in some of these assignments. But typically the main method is just for testing your classes. So if we can shift the issue to be in the main method rather than with our class, then that's a lot better. And of course we can do this by having this check around here. So now if the user keeps trying to take coins, it's clearer to them that it's their problem rather than it's a problem with the internal workings of our class. So protecting our array in this way is a really nice thing to do, because for many reasons, and one of them is that it's clearer to the user that there's been a problem there. All right, so now no one can take coins from our array again. Just go over this. So last coin has to be greater than or equal to 0. So this will be violated when last coin is -1. So when you've taken the last coin, obviously the last thing will happen is it will go from index 0 inside last coin to -1. So when you've taken the final coin in the chest. So of course next time you try and take a coin, this will be violated. So you'll just get this null return. And of course, part of the assignment, people I guess were concerned that I'd use this notion of positive and negative returns in quite a kind of abstract way. That was intentional. It was intentional for you to explore this idea of, well, what happens in the negative case? So you'd be familiar with Booleans here, the fact that you can return, if I could spell, it'd be better, you can return true or false to indicate positive or negative outcomes. Here the idea was to extend that notion to say, well, if I have to return a gold coin in the positive case, so when I take one gold coin, the positive case is gold coin, how do I then represent the negative case? So how do I represent the case in which I couldn't get a gold coin? Well, the answer is just to return null in this case. So you kind of indicate, it's like an object version of false, effectively. It's more than that, it's more important than that, but in this scenario, that's the purpose it's serving. We use null in this way to indicate that we haven't found a coin, that we have this negative outcome. All right, so that should be treasure chest done, which is nice. Again, this is just the most intuitive solution. There are perhaps refinements, but this is what I think is the most accessible way to approach things given what we've done so far in the course. All right, so I'll clean up my main method here, and I'll kind of put treasure chest to one side. That's done for now, I think. Again, you should be writing this code out. You should be comparing it to your solution. You should be working out, my solution was different there. How can I capitalize on that? How can I improve my understanding so I make sure that I don't make these mistakes again in the next assignment? Okay, and of course, if you're watching this at the time of receiving your grades, you should have already seen this video. This shouldn't be new to you. Otherwise, unfortunately, you're not approaching. I mean, I wish I could, make you watch these videos, but I can't. So unfortunately, you're approaching this feedback a little bit late, but still, it's things to learn. And you might see, therefore, why you've dropped marks and try and understand, really, why that's happened. Moving on to islands. So an island should be modeled as followed. Each island has a name and consists of a number of locations. Okay, so we need an island class, like this. Each island consists of a name. This should be easy by now. Private string name. Again, nothing assigned on the field. Not that you would anyway, but just want you to consider that rule of thumb again. Now it says each and consists of a number of locations, for example, a beach, a cave, the top of a mountain, etc. Okay, so I'm sure many of you would have seen this and straight away thought, oh, I need a location class. So something like this, you would have said, okay, I need a location class. You might have done something like this. And you might have said, well, all right, so I'm modeling a location class. What's going to be in my location class? I could have a treasure chest, right? Because obviously I need a treasure chest in my location to represent whether it's hidden or not. So chest like this, right? It's because, as we'll read on in a second, actually we can read on now, so the locations, each of which may or may not contain a buried treasure chest. So lots of you might have thought, well, we need a location chest here. And then you might have even said, well, I know I need a number of locations, so I'm going to make a location array like this, and I'm going to call this locations like this. Okay, I would have been fine with this. Again, style, I think, style choice. I mean, it's borderline, very, very borderline this time for the reasons I'm about to describe. But again, that could perhaps be a reasonable interpretation of how to do things. Remember, we looked at dish, which didn't do too much, but it was nice for extensibility. Here, though, I think this is very borderline because I'm not sure what else this class would hold. It could hold a string, maybe, to represent the name of the location. So I gave you some names of the locations in the brief. Things like, on a beach, top of a mountain, cave. But really, this was just for context. Okay, it's just so you understood the idea of the brief, the kind of scenario we were trying to model behind it. So this was really just for context. So there was no actual need to store, beach, mountain, etc. And hopefully this was a process you went through, because then you would generate your however many locations there are, 10 or however many you were given, and you would think, well, how do I know which is the mountain, which is the cave, etc. And the fact is, you don't know. So this kind of renders this field redundant. Again, it's borderline because there's an argument for extensibility here, but really I think this kind of errs on the side of kind of an inefficiency in terms of wrapping a chest now inside a location unnecessarily. All right, so again, very, very borderline, not something I'd mark you down for because it's kind of borderline style choice. Talking about location class, no, we don't need a I don't think we need a location class because I think that the merit there is reduced. I think that what we could actually do, and I think lots of you did this, was to actually store a set of chests directly, treasure chests directly. So again, we can actually go ahead and, well, I won't delete it, I'll leave it there just for posterity, and we can say treasure chest like this. Okay. Now, I think this would be quite a subtle thing for people to understand or employ. So this works because remember what we're modeling with this locations array. We're saying that we have a set of locations and they are empty by default. So there's nothing buried there, in the cave, the beach, the mountain, unless I actually physically go ahead and add something in there, which is exactly what we have here, right? Because we know, as we've looked at inside treasure chest here, that the values inside here are null. Remember I did this printing of the array before? We know that the values inside there, well, that was done manually, but you kind of get the idea. So we know that the values inside an array of an object type, and in fact this is the whole reason that we filled our array with coins, is because it was null if we didn't. Okay, so we know that the default values inside an array of a class type are null, so we can nicely model the idea that we have this set of empty locations, and it's only later on when we actually want to bury a chest in one of those locations that we've put an actual object in there. Okay, again, lots of nice alternate solutions here. Some people do booleans here, maybe integers. Not as neat, I don't think, in terms of representation, because that would mean that you'd need an extra field to store the treasure chest. And again, the general rule in this assignment is so long as the pirate can't cheat, so long as the pirate has to actually go through each of the locations on the island before finding the right location, and then getting that treasure chest, and so long as you have some way of indicating when the chest has gone, so that when the pirate returns to the island later on, the chest is indeed no longer there, then it's fine to say use something like boolean or integer here. Again, borderline style because slightly inefficient, but not something I'm looking to really to really comment on there. But yeah, treasure chest I think was the neatest solution here because again it allows you to directly store the chest rather than having to have any kind of supplementary field. So that's what we're going to go with. Again, just remember this idea of why does it make sense? Well, because it's full of null initially, and then when we add an object to it, we're effectively burying the chest there. So that makes for a nice representation. So again, maybe slightly more extensible with location, but of course we're not producing the most perfect solutions. We're producing those solutions that allow you to explore the capabilities of the language. And one of the capabilities is to have these partially filled arrays. In this case, just one location is filled, and how you kind of deal with that and the implications that has. Okay, so always not the most perfect solutions, those that are relevant for this point in the course. When an island is first created, a treasure chest should be buried at one of these locations chosen at random by the program. Okay, so when an island is first created, you should know, have seen by now that this is a clue to use a constructor. So when an island is first created, it should be possible to bury a chest should be buried at one of these locations chosen at random by the program. Again, I have to actually make my treasure chest array here like this, don't I? Because if I don't do this, then I know I'm going to get an error like we saw before, this null pointer, because this was just an empty variable effectively of an array type, unless I do this. And I'm going to need some values inside the constructor as well, aren't I? So if I say string name for the name of the island, and also what I want to have is I want to have int locations. Okay, so I'm going to do this, I'm going to have this name conflict between the field and the parameter, just to re-emphasize the use of this, or this keyword. Again, I wouldn't mind if you set this to fixed. I think I said this on the forum. I wouldn't mind if you set this to a fixed size of 10, so long as you did so properly, as in the same way that we did inside the chest. So long as you set this to a fixed size of 10, not just directly on the field, but inside the constructor using a public static final class field, I'd be happy with that. Because actually in the brief, or whatever size you're given, I think I had 10, 12. So whatever size you had here, I'd be happy for you to do that in that way. Because I think it's a reasonable interpretation that because all the burial sites have the same, burial sounds dreadful, bury locations have the same, all the islands have the same number of bury locations, there is this implication that that you could also represent the bury locations like this. So you could have bury locations, and in this case 12, and then I could write bury locations inside there. Okay, because I think it's a reasonable interpretation of the brief that that you could do that. But I'm not going to do that. I'm going to leave it variable in this way. And what I'm actually going to do is use the parameter to dictate the size here. Got an error, of course, because see these are all three of these are in this brown font color, when really we want this locations to reference the field up here. So I can simply use this to differentiate. And everything's fine. So I'm going to initialize my array to a certain size based upon this past locations parameter. And now I need to bury my chest, don't I? A chest. I guess I could say this.name equals name first, just for neatness. And then I actually want to put a chest in one of these locations, don't I? So this now brings us to the random, kind of the use of the generation of random numbers. The expected way to do this is using the math class, because this is the class that we looked at in the lectures. And I think it's reasonable to expect you to kind of make this jump that, well, math deals with numbers, so it's probably got a kind of random generation ability. So I can look at the math API and look through there and find this use of random number generation. I think that was reasonable. Remember, these assignments are all about just pushing it that little bit further to kind of investigate the ideas that we've seen in the lectures. So the use of random dot here was expected via the math class, but lots of people using the random class as well, which is fine, because again, at the end of topic 5, 6 maybe it was, on library classes, yeah, it was 6, we looked at this idea. I gave you 3 classes to look at for research, and one of them was random number generation, so you are absolutely fine to use it in this way. And in general, things that are referenced from the lectures are fine to use in the assignments, unless otherwise stated, or unless you're given additional freedom to use other things. So random was fine. I'm not going to use it. I don't tend to use the random class. I have a couple of reasons for this. I don't like having to make an object in order to generate random numbers. I just like the way that math works statically. I think that's nice and neat. But obviously there are a couple of drawbacks there, so maybe math is a little bit more complex to deal with in terms of the ease at which we can generate these numbers. But I like to use math. Again, style choice, not looking to mark you down for using random instead of math, or vice versa. But again, if there's any concern about the true definition of what constitutes style, then just follow what we do, really. Okay, so I want to generate a random number which corresponds to one of the indices inside locations. This is what I'm trying to do. So I've got 12 locations, but it doesn't really matter how many I've got yet, because this is variable inside the class. So what I want to do is I want to generate a random number between 0 and locations. There's brown locations here. Or between, even better, between 0 and the length of the locations array, right? Because I know I want to fill a random location in this array with a new treasure chest. Okay. And perhaps it's worth saying at this point that this is the first time really that we've properly created objects inside other objects. So we'll look in the next lecture at how this is an example of something called composition, but it's not something new. This is something I've looked at before, or at least alluded to in the lectures, definitely discussed in one of the solution videos, because we talked about how we might want to create a coordinate inside an aeroplane directly, or inside a destination directly. So here, this is still optional, so you could still create your coins, it perhaps be a little bit more clumpy, inside Treasure Hunt and pass them into your treasure chest. That's still possible. But remember now here, we're relaxing our rule of thumb that you create all your objects in the main to instead now create things inside the treasure chest itself, because it makes sense that treasure chest should have ownership of these objects. It should own these coins because they are from that chest. And again, that's something we'll talk about in the next lecture, but again, just pushing it a little bit further to explore these ideas. You weren't being tested on something that you hadn't seen yet, because we had seen this idea, and of course you could get away with not doing it like this. You could get away with doing it inside Treasure Hunt, that would be fine. But again, just pushing that little bit to kind of investigate these ideas. And again, of course, we'd seen this before, and I would never test you on something that we hadn't seen before, so it's fine to create these coins in Treasure Hunt if you want, but of course you should have naturally found that it was a little bit more efficient to create them inside the class directly. Okay, so we're going to see the same principle here when I create my treasure chest, which is what prompted me to discuss that. So first of all, I need to generate a random location, don't I? So I like to use math.random, and as you will see from the documentation, math.random produces you a random number between 0 and less than 1. Okay, so it's like 0.9999999. So if we run this, or I'm not making an island actually, let me just switch to Treasure Hunt, so I can show you the idea before I show you how to do it. It's going to generate this floating point number that's somewhere between 0 and 1, so strictly less than 1, I believe, or at least that's why this works. So of course, if we want to change the range, we just multiply it, right? Because if I want it to be between 0 and 2, then if the highest number I can get is 0.9999999, then if I multiply by 2, I'm going to get something like 1.999998, probably with an 8 somewhere at the end. Okay, so if I multiply it by 2, I increase my range, right? So now, as you can see, just because you can do these heuristic tests, you can see that I've increased my range here. You could never do it exhaustively, but kind of know now I'm multiplying by 2. I'm going from between 0 and 1.999999 rather than 0.9999, okay? Now we can capitalize on this nicely by doing the following. Okay, so I can cast the result of this multiplication to an integer. What that means is, of course, I will lose the ending precision, won't I? So if this happened to be, let's think about this, right? So if I multiply it by 2, it can go between 0 and 1.99999. So the only possible integers I can have here, if I do multiply by 2, are 0 or 1. Okay, so if I do an int here, I'm going to lose everything after the decimal point and including it, and get either 0 or 1, right? Because remember, just I guess play that back or watch that again if that doesn't make sense. If I do math.random multiplied by 2, then I'm going to go between 0 and 1.99999. So if I do this int cast here, I'm going to lose all of that precision, so the only possible numbers I can get out of this are 0 or 1. Okay, I guess you can just kind of heuristically check that. I mean, yeah, what's a statistically significant sample here? Probably not one I can obtain in a reasonable amount of time, but that kind of makes intuitive sense, I hope. So we cast the result, and we get this nice idea that the actual maximum number we can generate from our random generation is 1 less than whatever number we write here. Okay, which is nice and neat, because if I go back to my island, I can see if I want to access a random index in an array, I can write the name of the array, I can write this little random thing that I've just copied over here. I can actually change this now to locations, which is the name of the array, or I would need to do this dot locations. Dot length. Okay, then this dot locations like this, and then we can say equal. Just make it null for now, just so it doesn't show me any errors. Okay. What's going on here? So what I'm doing is I'm generating a random number. Remember, it's between, because of this rule I just showed you, it's always between. It's always 1 less. The random number generated is always a whole integer that's 1 less than whatever's inside here. This number here. So this was 2 before when I did it inside Treasure Hunt. See, that was 2, and that generated me a number between 0, which was 0 or 1. Same process for length, right? So if this length is 3, then I'm going to get an index, a random number of 0, 1, or 2, right? 1 less than what's inside here. So this is perfect for indexing my array, because remember, I always want 1 less than the length. I wouldn't want to generate a random number that was inclusive of the length, because otherwise it would get this index out of bounds exception. This is why I think math.random, again, you can do similar things with random.nextInt, but this is why I think this is neat. It makes sense. I really like this form of accessing random indices in this way. Okay, so don't forget your thises, this clash here. Just nice to remind yourself, which is why I've done this, of the difference and the way you can use this. Always good to practice these things. Okay, so I think this is a really nice way to generate random indices here, because you can use, it's very readable. You can see I want this random number, or at least I think is readable. Style choice, I suppose. You get this random number, you multiply it here, and because you cast it, you always get 1 less because of this precision. All right, so convince yourself of this, try it out, see what's going on, try it with simpler examples, maybe with 2, see why this works, and this is the way I like to generate random numbers for myself, especially in relation to arrays, because you can work with the length in this way like this. Okay, so we don't want to add null here, obviously, do we? We want to bury a treasure chest. So we want to make a treasure chest object and bury it. I saw some of you passing it through from the constructor. Again, fine. Remember what I said before, we haven't fully looked at creating objects just inside a constructor of a class, so it's fine to kind of do it still inside main. But of course, if you wanted to kind of take this step ahead, you're welcome to make things more efficient by actually making your objects inside the constructor like this. Okay, equals new chest, excellent. So exactly what the functionality we want now, right? We want one index of this locations array, which is all null, except for treasure chest. We want it to contain this chest object. Okay. So again, using this arrays method, and a very nice thing to use, we can say, after we've done this, we can say system.out.println arrays.toString, and we can this time we can say locations. Remember this dot locations because we have this local scope name conflict, and then we can run it and we can see what happens. Okay, and we want to see this hidden chest in the array. So I can make my island, new island. I can call it, what are some of my islands? Nassau, apologies if I'm not pronouncing that correctly. And then I have 12 locations like this. Okay. So let's see what happens. So I make my island and it should pick a random position and bury me a chest there. Perfect. See this happening now? So this is the representation that we have. Again, see the use of arrays.toString, which I suggested to you in the in topic 7, at the end of topic 7, halfway through topic 7, wherever we got to in the lecture before this was released, this assignment. So you can see here, all null except one position, and if we run it again, you can see the treasure chest is moving each time, right? So each time I get a random island with a new treasure chest, which is awesome. Really nice, I think. Okay, so each time we run the program, treasure chest is buried in a new place. So obviously if we have 3 islands, they should, well, maybe they'll all be in the same place, but at least that place will be selected at random. So next, hopefully that makes sense. Always ask me questions if it doesn't make sense. Please always challenge what I'm doing. If you don't like my style, you think there's something wrong with it, especially if you don't like math, tell me why. I want to learn, I want to know what you think, and we can have a good discussion about this, especially on these aspects of style where there's really no right answer. Okay, really love the engagement that you guys are giving me this year. It's fantastic. Okay, so we have, let me get rid of arrays for now just to keep things neat. Eclipse always has this extra line at the top, fair enough. Okay. It should be possible to, so we've done the treasures buried now. It should be possible to dig at one of the locations on the island, as indicated by a supplied integer. If after digging a location contains a treasure chest, it should be removed. So again, something about null there, similar to the coins, from the island and returned as the result of the dig. If a location does not contain a buried chest, then naturally no chest should be returned because there wasn't one hidden. Appropriate steps should be taken to ensure that the integer supplied corresponds to one of the available locations on the island, and if it does not, then again, no chest should be returned. Dig, this is the name of a method. I know it's got to return a treasure chest, right? Because digging results in you getting a treasure chest back, and that's what it says. A treasure chest should be returned. It should be returned as a result of the dig. So I know it's called dig, and it says that I need to supply some integer. And what this integer is actually referring to, which you can probably work out, is the place in which to dig, right? So this treasure chest consists of a number of locations, and each of those locations, because it's an array, has an index. And it just so happens in my example, as we'll see later, or we can actually see already, there are 12 locations, so the index goes from 0 to 11. So if a pirate or anyone else who's searching this island wants to test one of the locations, so test one of these places down here, to see if it contains a chest, they first have to say which location they want to access, right? They have to say, well, I want to look in the first location, so that in that case they'll give me a 0. Or I want to look in the third location, in which case they'll give me a 2. Okay, so you can see this correspondence here between the index that we supply and the idea that this then allows us to interrogate this locations array and find which position contains the chest for our use, or to dig up effectively. Okay, so now I need to supply this dig location, and I know that I need to return this as a location to the array. All right, so not a difficult method at all. So we need to say locations, and of course we know we access an array using square brackets. We just did it here, and we need to then actually use this dig location directly and then return this from the method, right? Very, very simple. So it's effectively, this method just wraps around the access to an array, right? And we give it a number, and it will then access that array at that index and return whatever's there. And it's fine, remember, because we have this flexibility. Again, part of this assignment was getting you to look at the flexibility of null, get you to look at this idea of how null can stand for positive or negative things. In the same way as taking one gold coin returned null in the negative case, this will automatically return null for us, won't it? Because if the location is empty, like it is down here, we'll just get a null, which is fine. It's for someone else to deal with when that's null. We're using null to indicate that these locations are empty. Okay, good. So this kind of takes care of most of this little 3.2, the question here, but not quite the last sentence. So it says steps should be taken to ensure that the integer supplied corresponds to one of the available locations on the island, and if it doesn't, then again no chest should be returned. So we want to say if, sorry, what do we want to do here? So of course, if someone says, let's actually do this. If someone says island dot dig, 200, then that's not right, is it? Because there's no 200th location. So we definitely need to say if dig location less than locations, right? Or sorry, no, locations dot length, right? Because we don't want them to be able to dig in a position that is greater or indeed equal to the length, right? Because if it's equal to the length, that's a non-existent index. That's not going to work. So let's see what happens. Actually, we can actually see what happens if we just went ahead and tried to do that. We try and do island.dig 200, index out of bounds, right? There's no 200 because this length of this array is 12, so the last available index is 11. So we indicate this by saying dig location has to be strictly less than 12, which is 11. That's the maximum it can be. And it's the case, of course, similar case if someone's playing silly beggars, they try and do -1, going to be the same. Oh, if I can run it, that'd be nice. Going to be the same problem, right? There's no -1 because it starts at 0. So to test, we need to say, basically saying, has someone entered something sensible? Dig location needs to be greater than 0, and it needs to, both need to be, if one of them is violated, then the whole thing, the whole expression shouldn't be evaluated, the whole block shouldn't be entered, sorry, we shouldn't enter this conditional block. If either of these operators gives you a false result, so we use this logical AND, so that they're both tested, wouldn't be sufficient just to do or, because we're specifying this range. Imagine if I did or, right? So if I did or down here, then actually just down here I'm going to do return null. I'll explain this in a second just to make it behave. So if I did or down here, remember, as soon as one of the operations in a kind of joined composite or statement here is it's the two operands to the left and right of an or operator. If one of the on the left evaluates to true, then we just go ahead and do it, right? So this wouldn't protect us against. It would protect us against -1, but it wouldn't protect us against 200, right? Because this is fine, so Java just assumes, well, that's fine. So I know that in order for an OR to proceed, only one has to be true. So if the first is true, I go ahead and do it. So I can't do an OR. It has to be an AND. Okay. And this will actually be fine now, because if someone tries to do something silly like enter 200, then nothing happens, which is good. Again, style choice. Indicate style choice alert, so you could do an else here to return a null. I tend to, quite honestly, I'm not very consistent with this. I should try and be more consistent. But more often than not, I'd say 99% of the time I don't do this. I just return a straight null because I'm always looking for the slimmest solution, right, with the least syntax. So maybe you could argue it's more readable here to actually write else, because you can see there are two distinct outcomes. But generally I write null here, and that works obviously because if this is satisfied, it will return here, so this will never be reached. Okay, so we can kind of get this functionality. Again, maybe given what we've looked at this idea that you shouldn't really use return statements for control flow, so maybe I will leave it in actually. But again, this is something I need to tighten up on. So it's a style choice very much, I would say. But what I would say is if you're doing this in terms of if statements, a large number of if statements, I think that's wrong. Okay, so I've seen some people in some of the assignments doing if something and then return here, and then if something else, and then return here. I think that is crossing the line. Okay, so there is a line, not in a bad way, not in trouble or anything like that. I'm just saying in terms of style, it's crossing the line because here you are using if state returns in a bad way rather than using an else if that makes sense. So to control your code in that way, and I actually had a slide on this, and this not being right wouldn't be right because you had the option of an else if. But I'm a little bit more relaxed in terms of if it's just a single if else to have return here. Okay, if that makes sense. But again, just to keep things consistent, I will go with the old else here and make the most readable as possible. Alright, so not okay to ignore else ifs on a big way just by using returns. I don't like that. Just using ifs with returns is a bit mucky. But if you've just got this single simple if here like this, then I think it's okay just to return null in that way. And actually, I've actually already done it down here, so let's at least stay consistent. Okay. Good. So done dig. Nice. Finally, it should be possible to access the name of an island and the number of berry locations, which suggests we need that later. So let's just make some simple accessors. Public string get name, so we return the name of the island, and we say public int get berry locations, return locations, yeah, .n. All right. So here we want to understand the number of locations that there are on the island, so we need to return the length of the locations array. Again, if you decided to do this as a public static final field, then you wouldn't need this. Of course, you'd access it through the class directly. That would be fine. But again, remember, I didn't want you to see something like this equals 10. If you're going to have these constants in there, then they should really be defined as public static final fields. Okay, that's a nice way to declare, because obviously if you were going to say 10 is a constant here, it needs to be declared in the proper way, in the same way that we declared this constant of 18 here and then used it rather than the actual 18 throughout our program. Good reasons for this, of course. If I decided this is now 19, much easier to, because everything else gets changed. I was just pointing at my screen then, as if you can see that, and then everything gets changed inside coin chest here, and that's good. All right. So nice accessors here for get name and get berry locations, and we're moving on rapidly, which is nice. A pirate should be modeled as follows. A pirate has a name and a purse which can hold a number of gold coins. This should be easy now, because really these assignments, we're just building things up. So now we should be quite comfortable with the idea of what it means to have an array of objects inside another object, or an array of class type inside a class. So it should be clear what's going on here and how to do this. So pirate has a name. Very straightforward. Pirate has a purse which can hold a number of gold coins. Already done this inside chest. I know exactly what's going on here. Yeah, so I'll just type it out to avoid my notorious typos. Gold coin purse. Yeah, very similar procedure. Pirate also has a map. Okay, I'll come back to that in a second, which depicts a number of islands. Okay, so let's just fill in the constructor first, or at least part of it. So we could say pirate string name. Remember, always do what you can when you're first working, and then purse equals new gold coin. All right. So here again, there was a number of options. If we're going strictly by what we were looked at in the lecture, then now we see a situation where we have a fixed size and array. We're being forced to specify a size here. It won't compile unless we do. We're being forced to supply a size of an array for the pirate's purse, right? But what do we choose? We don't know. We could. A reasonable way to do this would be to calculate, well, there's, certain number of islands, certain number of, there's a chest on each island, therefore there must be a certain number of coins. That would be a perfectly reasonable way to do it. Again, this is verging on a style choice or your interpretation of the brief. But if we're going strictly by the definition in the notes about what you should do here, then really we should just supply an arbitrarily large number. Remember we looked at this idea? So what happens if I don't know how much input I'm going to have or how many objects I'm going to store? Then I just choose an arbitrarily large number. But again, this is just, I think, the nice way to deal with this. Those of you who calculated the exact number of coins, also fine. Those of you who actually increase the size of your array, kudos, that's good as well. But of course, slightly hacky, really increasing the size of a fixed size array, really dealing with these fixed sizes and realizing how awkward it is, particularly in things like this, having to declare a huge number for an initial fixed size, is part of the motivation for topic 8, which was looking at these data structures which expand and contract automatically for you. All right, so nice here. This is what I would have done. I would have done a huge size just to keep consistent with what I've looked at in the lectures, but there were other logical choices here which were also fine. Let me assign my name to the field. Okay, so a pirate also has a map which depicts a number of islands. Okay, so this is something that I'm going to want passed to my pirate eventually, which I think is said down here. So I'm told to create a map with 3 islands. So let's actually, as I like to do in these videos, let's leave our classes here and jump ahead and start doing the actual implementation, or sorry, the use of the classes, which is always question 2. So I've got my class treasure hunt, everything compiles. Sorry, just to take a step back, everything compiles here. I'm just leaving it, I'm setting it aside temporarily while I now go back and try and actually test some of these things out. Okay, so I'll put these in order. So gold coin, treasure chest is made of coins, islands made of treasure chests, and as we're going to see in a second, pirate is kind of made of, pirate's made of lots of things. So it's got a purse and he's going to have a map as well, and we'll see how that all fits together. But first of all, it says create a map. I'm going to go to question 2 now. So create a treasure hunt, which I've done. Compiled and run from the command line. Great. Use this class to do the following using the methods that you've created in question 1. And then this thing about pirate speak, which I'll come back to in a second, which I know many of you found truly cringe-worthy, which I love. Brilliant. I like a bit of cringe, but we'll look at that at the end. Create a map with 3 islands. There should be 12 possible berry locations on each island. Add these islands to the map in the following order. Okay, so there's no special font here on map, but there was above, so it should be clear that we have this lowercase map here at 4.1. So it's clear that it's something, but it's not got an uppercase M in either the font, the font or not without the font. There's no uppercase M, so it's a hint to you for it not to be a class, right? And it's the same approach as for a treasure chest, right? So we first of all, remember I showed this example with the treasure chest, where we talked about maybe I could have coin 1, coin 2, coin 3, coin 4, etc., etc., etc. throughout the chest. And really we could actually shorten that process by creating a single multi-slot variable, which is an array, of course, in the simplest terms. So here with the coins, that's what we did. And actually I think the same process is good for map, right? So maybe people were asking, do we have a map class? You could do, but again, I don't think that's a logical choice, given, what would it store beyond getters and setters, and it would be hard to, make this, kind of be inefficient to have to write out all the fields. Maybe not so much for 3 islands, but imagine if in the future we wanted more islands, it would be difficult to update this map class in that way. So yep, you guessed it, map is an array, and it makes sense because, we've looked at how islands consist of treasure chests consists of coins. So it makes sense that a map consists of islands, right? Because if you're a pirate, that's what is on your map, right? A set of islands. So conceptually, I think that's sound. So island array, I'm going to call it map. And just to show off the flexibility of array declarations, we know what's going to be in this array to start with, don't we? We know there's going to be 3 islands. So I'm going to make my 3 islands straight up. So it's going to be island Nassau. Again, apologies for incorrect pronunciation. 12. I'm going to say new island Havana. Make this 12, and importantly I'm going to say new island St. Kitts, which has a space in it, which you would have had to work with, 12. Okay. Alright, so again, let's look at this flexibility. So before we've seen this idea that we declare an array in 2 parts, so we make the field here and then we actually put effectively an object in that variable to make this array, and then we access things index by index. Remember we have this nice shorthand, so that rather than saying something like pirate map equals island 3, and then we actually go on and say map 0 equals new island, etc. We do have this nice shorthand where we can, declare declare and initialize this array in one line, very similar to what we do with an integer when we declare and initialize in one line. Same for the map here. So we know this is going to contain 3 island objects. You could maybe argue, so again, you guessed it, this is a bit of a style choice. You could maybe argue that this makes map less extendable. I mean, really, you could come along in the future and just add a new island, I guess. So it's a fun issue to debate. But I think, again, just in order to show you the flexibility here, doing this single line declaration will be useful for you to see. But of course, you could replace this with the 0, 1, 2, 3. 0, 1, 2, and the size of 3 for your map if you wanted to. Okay, but I'm going to stick with this because I think it's nice to experiment with. Okay, so we have the map. Great, there's a map. It exists in our world. The main method is basically our world. There's a map. Now we need a pirate, right? So I've done 2.1, made my map, given the information, because remember I made the appropriate skeleton, no pun intended, inside island. Pirate's not quite ready, but he's still compiling and ready to be used. His constructor's there at least, partially. So create a pirate with an appropriate name. For example, Captain Chapman or Chatbeard, aren't I funny? You could, I hope you chose your own pirate related name. I'm going to go with Captain Chapman because I love that. So I'm going to say pirate equals new pirate, name Captain Chapman. And it says here, this is the crucial thing now, right? It says this pirate should also have the map created above. Okay, so I'm going to have to pass a map to my pirate. Exactly the same process as for putting dishes inside meals. You make the dish, you give it to the meal. Here you go, you make the map, you give it to the pirate. Okay. Obviously this will necessitate me changing the pirate's constructor in some way, so I need to say island, which is an array. Remember, if you want to pass an array to a method, in the same way that you would write the normal class type here, you instead write the class type but as an array, the same way you'd write something like int here to pass an integer array. Here it's instead just island, and we can call it map. Okay, so then I need my pirate to hold his map like this, and I can say this dot map equals map. Okay, so the pirate is holding his map here. All good, all dandy. I want to give, so now everything works, given the pirate his map, and we're all good. Just do a quick compile, nothing, no runtime errors or anything like that, all good. Always good, especially when you're working with arrays, to just periodically check, even if your code compiles, that you don't get runtime errors. Again, all about breaking the assignment down, solving it bit by bit, testing it all in the right way. This is a good way to approach these assignments, especially ones that are this tricky, but of course this should be the last one of this difficulty this term, because you've got other things to think about in the next few weeks. Pirate has the map, and what now? So we're going to jump back up now because it says allow the user to suggest. I want to talk about that later on, so I'm going to jump up back now to 4, where we're going to talk about search. I'm going to talk about 4.2. Pirate has the ability to search for an island, which should involve the following process. So the search starts with a name, which may correspond to an island on the pirate's map that contains treasure. So again, I know I need a search. Okay. Starts with a name, so I know I'm going to need search. It's called search. Starts with a name, so I know I've got string name. And I know that it needs to be corresponded to, or it needs to return, if I look ahead at 2.2, an island. Okay, so you see all of these method declarations are quite intuitive. So a pirate searches for a name and returns an island. So someone digs for a chest at a location and returns a treasure chest. You see what I mean? So they're quite intuitive. Someone takes 1 gold coin and they get a coin back. Okay, so they're very object-oriented programming, especially in Java, is very readable. So if your methods are readable, then usually you're kind of on the right track in that respect. Again, it's all about making your program more accessible and readable to someone from the outside. The search starts with a name, which was a hint that you need a name parameter, which may correspond to an island on the pirate's map that contains treasure. Name is passed to the pirate, which suggests that inside treasure hunt, we're going to need to do something like pirate.search. I'm going to make him search for Havana, because it's the only one I can say right. Or definitely not spell right, though. Havana. And I definitely can't spell search. So I know this is the functionality that I want. So it starts with a name, Havana, which may correspond to an island, one of these, on the pirate's map, which may or may not contain treasure. Well, it will contain treasure at first, but it might not if the pirate goes back to it, as we'll see later. The name is passed to the pirate, pirate.search Havana. See? And the pirate then searches for an island on their map with this name. If an island with the name is not found on the pirate's map, then a negative result is returned. Otherwise, the result is the correct island. Again, testing your notion of what negative will mean here in this case, right? Because we know we can't return a Boolean, because we have to return, again, if I could spell, because we have to return an island, right? So the only possible thing this method can return is island. So if I try to do something like return false, obviously, it doesn't work. It's again getting you to think about, how you can use null in this way, which is, of course, what you hopefully came up with for that outcome. So how am I going to search? Well, the search procedure is very simple. The pirate's going to simply do a kind of brute force, you could say, search for an island with this name. And what he's going to do is he's effectively going to do this if statement. He's going to say if name, yeah. So let's actually just say this. So let's make it simple to begin with. Let's say map.0. So let's assume that the right island that you're looking for is always the first position on the map. So we could say if map.0 = name. Then we want to return map 0, right? So what we effectively want to do is we want to go through, in this case we're just making it simple. It's always nice to start with simple cases, as you can see in things like the noughts and crosses example. So we want to say if the thing in the 0th position of the map is equal to name, so let's imagine this is always the case that what we're looking for is in the 0th position. And I obviously want to return that island, don't I? Because there's island objects in the map array. So I'm basically saying here, look in the map array, look at the first position in that map array, the result of which is going to be an island, because it's full of islands. Is that equal to the name that I've passed? Okay, so remember, map.array, oh, I missed a step. dot get name, sorry, dot equals name, of course, because this is just an object. So you could do dot equals, but it wouldn't necessarily give you the behavior that you want. And I need to get the name back first, don't I? Because the result of this is an island. So I know I can call get name on an island because it's a method that I've written. And then I know that inside Pirate, I can now interact with the result of this. So the result of get name inside island is a string. So I know I can interact with this and check, is it equal to the name that's supplied to the search? If the name stored inside that island object that's represented by this is equal to the name supplied, then I know that's the right island that I want to dig on, right? So we've got this idea that there's one representation of islands in the Pirate's map in object form, and then there's the representation of islands in the user's mind, or what they can type in on the keyboard, that are strings. So what we're effectively doing is we're saying which island has this string in their get name field, effectively, because we're using this way to correspond names to objects. And to do that, we're doing this quite brute force approach, which is to actually go through, look at each object and say, is the value in your name field equal to what I've supplied? If it is, then you are the object that I want. So this is the same object. If your name is equal to the one that I'm looking for, if the name of this island on the map is equal to the one that I'm looking for, then I'm going to return the map from the method. Make sense? So I'm corresponding each name of each island on the map to the name that I've supplied. If it's correct, if it's equal, then that's the island that I want. I'm corresponding a string to an object, which is important because the user enters and thinks in strings. The actual treasure is stored inside an island object, right? So there's this correspondence that we need to go through before we even start trying to get this treasure out. Of course, I don't always want to look in map 0, do I? I want to look in every position on the map. So I could do this. I could say for in I equals 0, I is less than map.length, I++, and I could say if that, then I return map I, like this. Of course, because I don't just want to look in 0 here, I'm going to look in 0, 1, and 2, right? So I'm going to automatically go through the whole map. Again, nice to have a loop like this, because although map is only 3 sizes now, could be more in the future. Could add, where are we? Could add objects into here. So nice to have this loop. And then obviously if the loop ends and nothing's been found, then return null. Again, it's okay to use return statements in this way, because of course there's not really any other option, because once the loop ends we could have a flag or something like that, but this is the neater way. So here again, I would advise you generally not to use too many return statements to control the flow around conditionals, but here I think it's fine. So as I said before, if you're using kind of if and then return, if return rather than if, else if, else if, else if, else if, because you've got a nice simple straightforward alternative there, don't do that. But here I think it's fine, because the alternative would be a little bit wordy, so to speak. It would be a little bit, introduce a little bit of extra overhead there, a bit inefficient. All right, so good. So this will allow us now to return the object that we want. Okay, so should we try it? What happens here? So we have an island, don't we, with a name. So let's see if if we can ask the pirate for the island with a certain name and see if those names correspond. So we know that search returns an island. So we can now call any method on that island. So I can call get name. So this is just a string. So let's see if this now tells me that this is Havana. Havana, great. Brilliant. I'm sure you like my little pirate voice then. This is equal to Havana. So this is good. So what happens if we enter something that doesn't exist, like United Kingdom? Error. Okay, good, because it's returning null, right? Because this loop finished without returning anything, so this if statement was never satisfied, so I return null. Okay. Could make this a bit more straightforward, and I'm going to, because I want to show you a different kind of loop. So remember we had this for each loop. So the for each loop will avoid us having to do this index process. So here I can simplify this down. I can say I just want to grab each item from the map array temporarily. So I could do something like island, current island. I do this colon and write map. Then I write current island dot get name here, and then I return current island. Okay. Does that make sense? So again, we looked at this in the notes. So this is going to automatically extract each element from the map array and store it inside this current island temporary variable, which we can then access inside that iteration of the loop, and it will contain the current value from the current index inside map. So first right time round, this will contain this Nassau, again apologies for pronunciation, island object, then Havana, then St. Kitts. So first time round Nassau, then Havana, then St. Kitts. So it produces the same functionality. Why can't we do this for coins? Well, once we have this temporary variable, it is indeed temporary, so we generally can't use it to interact with the array. So I couldn't say something like for gold coin colon coins, coin equals new gold coin, right? So I couldn't do something like this. I couldn't do gold coin inside coins and then say coin equals new coin, right? Because I'm not updating anything inside an index here, right? This is just a temporary variable. Remember scope. Once you end this for loop, it's lost. It's gone. Even actually after the next iteration, it's lost, isn't it? So I can't use this to interact with an array, this advanced for loop. I can only use it I can't use it to update an array. I can only use it to get the values out of an array in that way. Hopefully that makes sense. So remember, you think about scope and this temporary variable and the effect this will have. Actually, good exam question, that. So there we go. This is the functionality that we want. Let's check it still works. So Havana, UK, null. Great, still working. Okay, so we search for the name, we search for an object corresponding to that name. That's the purpose of this method. Nearly there. So that's 4.2 done in parts 1 and 2. So now we have to say a pirate has the ability to get treasure buried on an island, which should involve the following process. So a pirate attempts to get treasure on an island by digging in each location to see if it contains a treasure chest. So I know I have some method. Pirate attempts to get treasure on an island by digging in each location to see if it contains treasure. If no chest is found, a negative result is returned. Okay. If a chest is found in one of the locations, the pirate takes the coins from the chest until all the gold coins are taken and places them into their own purse. Once this is done, the treasure is obtained and the result is positive. So we know that actually once this process is done, the pirate's got the coins from the chest, they're all in his purse. There's no need to return anything back, right? There's no need to return any objects back, because there's nothing more that's done, right? The game, so to speak, is over. The pirate has taken the coins from the chest, and they're now safely in his purse. So I don't need to give any objects back as a result of this. So now I can take the literal interpretation of positive and negative and just write Boolean, right? Because if the treasure is found, then here you go, here's your true value. If it's not found, here's your false value. Makes sense? So there's no objects that I need to return here. It doesn't make sense to return any objects. They wouldn't really go anywhere. The game is over, so to speak, once this method finishes. Either stuff has or hasn't happened, in which case you need to do more actions. So a Boolean here is sufficient. So I know it's called getTreasure. Yeah. And it's not going to take any parameters because we want, I mean, again, this is something that people, that you need to elicit carefully from the brief. So the process of getting treasure, the process of digging in each location is not instructed by the user. Okay, that's not said anywhere in the brief. There's nowhere in below in question 2. There's nothing about the user specifying dig locations. It only says user suggests the name of an island. Then it says the program prompt. So prompt the pirate to bury the get treasure. That's you the programmer with the program, not the user. And this is again reinforced by the fact that it says a pirate attempts to get treasure by digging in each location. Again, so it wouldn't make sense for to have any input here to the method. Instead, there's this self-contained functionality about how a pirate digs through each location on an island. So what do we want? What we want to do is obviously call dig on an island. Actually, I'm talking nonsense, aren't I? It does need to take something. It needs to take the island on which to dig, doesn't it? Of course. So get treasure from an island. Absolute nonsense. There we go. So, you know, we supply get treasure to this method. Here we go, of course. So first of all, I thought it didn't need anything, right? But then you look through the assignment, you think, well, actually, you need to actually dig on an island. So we read it, don't we? We say, a pirate attempts to get treasure on an island by digging in each location to see if it contains a treasure chest. So it makes sense to supply an island, of course. There we go. So get treasure on an island. Again, why did I know that was wrong? Why did I know that I'd missed something out here? Because I read it and it says, well, public boolean get treasure. Get treasure where? See what I mean? There's 3 islands. Which island is it? All of the islands? No. 1 island. But the point stands about user input, right? This is not something that's input directly from the user. They're not inputting dig locations. Instead, you're going to use the result of search to pass, an island object to get treasure, and then the pirate can extract the treasure from the island. You see? So extract the treasure from the island. How did I know that I'd missed something out there? Because it's not readable, because I look back at the brief. These are the processes to go through just to confirm that you've got the correct understanding there. Again, it's almost like I didn't do that on purpose. A pirate attempts to get treasure on an island by digging in each location to see if it contains a treasure chest. If no chest is found, a negative result is returned. So what we're going to say, well, I need to dig somewhere, don't I? So island.dig. Good start. Where do we want to dig, though? What we really want to do is we want to think of some strategy for the pirate to dig in each location on the island in the most efficient way. So if the pirate knows that there are 12 locations on the island, because he can ask them, you can say island.getVary locations, right? Because he can ask it, what's the most logical approach here? Well, the pirate could jump randomly around the island, right? He could randomly try locations. He could, do it in that way. But I don't think that, we're going to have a smart pirate here. He's going to do it in the most efficient way he can. And really the most efficient way is to try each location in turn, isn't it? So we imagine he has maybe another map, a mini-map, not of all the islands, but of his own island. Not something we're representing directly. But you can imagine he looks in a location, then crosses it off on his mini-map. How do we represent this? Well, quite simply, we want to loop through all the locations and test, is there something buried there? Okay, so we need a simple for loop that's going to go through and it's going to call dig for the number of locations, so 12 times, but it's also going to do so using a sensible ordering of dig locations, so the values that we pass, which is going to correspond to the value in a for loop. So I'm going to say for int location equals 0, location less than island.getVary locations. We know it has to be less, of course, because that's relating to an array. Then we say location plus plus. All right. And we want to then, make sense to dig in a location, right? So our code is still readable. So we want to dig in each of these locations. Before we go further, let's test out. Let's see what happens. Pirate, print line. Again, always good to test things as you go. The result of a dig is, yeah. So I'm asked to return a Boolean. So let me say, just to keep the program happy, let's return true for now. Let's go back to my treasure hunt and let's see what happens if we do this. Let's say system.out.println, and let's make our pirate get treasure on an island. So we know that result of pirate.search is island because I've seen it inside my pirate class, and there it returns me an island. So I know I can pass anything that's returned from pirate.search to the getTreasure method because the getTreasure accepts an island. Yeah, so I know that I take this result, which is an island, and pass it to getTreasure. So I know that I can then successfully invoke two methods in one call and print the result because I know getTreasure returns a Boolean, so this is going to return me a true or false. More importantly, for now, I want to see what the result of the digs are. Okay, let's see if this works, or do we get some kind of error? Let's see what we get. Ooh, looks okay, doesn't it? Alright, so what have we got here? So we can see now that our program is starting to work in a way that we want. So we found Havana, which is nice. This we must have done, otherwise this would have given us a problem. Let's see what happens if we entered UK. Would we get a problem? Yep, and get a nice null pointer exception there. We'll deal with that later. But if we enter Havana here now, we can say, right, so I'm now going to search through Havana to find what's in each of these locations. So what the pirate's done in this specific example is that he's had to dig through every location, right? Because the poor guy, it just so happened that the treasure chest was randomly hidden in the final location. So in cases like this, obviously it's a bit inefficient, but I think this is the simplest approach at the moment, this kind of brute force search. Go from 0 all the way up to 12, 11, because I've got 12 slots in my array, or indices, sorry, to be more formal. Yeah, I do, so 0 to 11. It's gone 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Tested all these, and of course ignore the true there, that's just me doing that. In fact, I could, I don't actually even need the print here, do I? Because I'm not yet examining the result, but that just proves it works. There we go, so we test all the locations, and 1 each time contains the chest. So I know now that my pirate's definitely going to find the chest on this island, isn't he? Which is nice. Good. There we go. So yes, he's got the chest now. We know he's going to get the chest, but what do we do here? So we don't want to dig if there's no chest there, do we? We want to say, if the result of the dig is null, which we can see it is in many cases, we don't want then to proceed and try and grab coins from that chest, do we? So we want to say if island.dig not equal to null, don't we? Okay, so we want to say if island.dig not equal to null, then we want to say system.out, and let's actually try and wrap that in my statement. First of all, this is leading towards a purposeful mistake. If island.dig location not equal to null, then we're going to go ahead and say the result of the dig is this. And let's see what we get. Okay, So here we can see the result of the dig is null. So what have I done? So inside island. There's something I've missed, isn't there? What have I missed here, friends? I have missed setting the location inside island to null. Okay, so what should happen here is we'll explain in a moment. But what I've missed is actually setting the dig location to null, haven't I? So again, remember these videos aren't supposed to be perfect. You know, you want to see my insights. Obviously, I make mistakes all the time. So I want you to see me working on this solution. I want you to see me going backwards and forwards. So I know this might be frustrating for those who are writing from start to finish. And I appreciate that, you know, maybe making it a bit more polished so I could practice beforehand. You know, I could do it a couple of times and then give you a perfect version. But I don't want that. I want you to see the raw programming process, which does go backwards and forwards. So again, these videos aren't designed to give you a beginning to end solution. They're designed to allow you to see into the mind of someone else programming. That's their real aim, really. I mean, showing you the solution is one thing, but really you want to look into the mind of someone who's coding. Not necessarily an amazing coder, but just someone else who is coding, anyone. Okay, so again here I've had to jump back because I've noticed that I've missed something out, and again that is to be expected. So what have I missed? Well, here inside take one gold coin, I set the position or the value that I've taken from to be null, but I don't do the same thing inside dig, which I should. Okay, because the chest is taken, and I think that's given in, or at least strongly implied at the brief. So I say, where's my dig? It should be possible to dig at a location. It says that the chest is should be removed from the island. Yeah, so this chest should be removed from the island. So I'm not removing it. I'm just referencing in the same way that I was removing a gold coin from a chest. So I need to do that. All right. So what we need to do is the same process, exactly the same temporary variable. I won't talk about it too much. We say treasure chest, dug chest equals locations, dig location, like this. Then we say dug chest equals null. Not a big issue that I missed it because it was the same process for, sorry, not dug chest equals null. Dig location equals null. That definitely will give us the wrong behavior. So then inside treasure chest, we did the same thing, right? We saved it, made it null, and then returned it. Here you see, saved it, made it null, and then we don't return that because that will be null. We return dug chest. Yeah, makes sense? So here, rather than doing minus minus or anything like that, you know, we're just making that single location blank. We don't need to update dig location. Unlike, you know, last coin here, which was actually handled by the class, dig location is handled by the pirate. So we don't need to minus minus or anything like that. We just set the location that they've tried to extract from to null. Okay. Now that this is working properly, this will give us a strange result, right? See this? So I've said if dig location not equal to null, then the result of the dig is null. That's a bit weird, right? Because I've just said if the dig location is not equal to null, then the result is null. How's that possible? How could it have not been null here, but then null down here? And this is the mistake that I saw, or an issue that I saw most people having last week. But you just have to think about it carefully, right? So what does island.dig do? Island.dig is not just an accessor, which is what it might look like. It's actually also a mutator. So that this is a common thing to kind of mix up, the fact that methods aren't just always one or the other there, and I said this, you know, methods can sometimes be more complex things. They are, by definition, not just getters and setters. That's what we've got here, right? So it might look like a getter, like it just gets you, where have we gone? It might just look like it just gets you a value, but really it does more than that, right? It actually sets that value to null. So we can only actually call island.dig once for each of our locations, because once that's called, if it happens to be where the chest is gone. So I can't call it again. I can't dig, remove the chest, take it back to my ship, and then come back and dig and expect it to still be there, right? It doesn't make sense. See what I mean? So if I call a method that might look on the face of it just like it's an accessor, but it actually does more work, I need to be careful, right? Because here you can see the work that's done is setting that position to be equal to null. Can't do this then. I can't dig more than once, so I have to be careful, and in a very similar fashion as I did inside the chest with the temporary variable coin to take, and inside the island with dug chest, I can do the same here. I could even call them the same thing. I know dug chest isn't really very good grammar, is it? No, we'll go with it. So we could say treasure chest, dug chest equals island.dig location. I could say dug chest not equal to null. And I could say dug chest here again. You see what I mean? So I make one call to island.dig and save the result. So the action has happened once, you know, and that's fine. It's happened. It should only happen once, otherwise you try and dig multiple times, as I've said. And you then store the result in dug chest, and I can then use it as many times as I want without further implication. So if I call it now, you see I've got my treasure chest. It's there, saved and ready for my use. Makes sense? I hope. Again, Engage with this, let me know if something doesn't make sense, and I will explain. Okay, got the chest now. Perfect. What do I want to do to the chest? So it says if a treasure chest is found, so which is good, which it is, but it will be inside this if statement because it's not equal to null. That means there is a chest in the location. Then I want to take coins from the treasure chest until all the coins are taken and placing them into the pirate's own purse. Okay, quite tricky this bit, I think. Again, I saw people struggling with this. Lots of ways to do it. Saw some while loops. That would work. I'm going to go with a simple for loop just because I think it's more readable. So I'm going to say for in I'm going to call it coin equals 0. Coin less than treasure chest. Okay, now remember I'm going to access this directly through the class because I know coins in chest is static, so I should always access it directly, which is nice. This is part of the flexibility that declaring these public static fields, final fields gives me. It gives me the ability to not have to interact with the object. I mean, I already have the object here, so I could do it through the object, but it's neater and more readable and cleaner to do it this way, I think. Again, perhaps a bit of a style choice there. So what I'm basically going to do is I'm going to go through this a number of times that is equal to the number of coins in the chest. So it's going to go from 0 to 17, which is 18 times. So what I want to do is I'm now going to call this nice method that I have waiting for me, take 1 gold coin 18 times, which is right because there's 18 coins in the chest, and I'm going to go that way. So again, people did while loops here, maybe a bit shorter, actually maybe a bit nicer, but here I'm going to go for the for loop because again I feel it's a little bit more intelligible in that respect. Again, style, not something we're going to think about marking down, but of course we never really talk in terms of marks, only in terms of feedback and improvement. So, dug chest, dot take 1 gold coin. Nice. Remember again, I can't call take 1 gold coin more than once, which we'll see in a second. I actually need to do the same thing, right? Because I could do this extra check. I could say if dug chest, take 1 coin, not equal to null. I know this will never be true actually. So I know that it will never be true because I've carefully set up my loop bounds here. But I guess some of you who are using while loops might have run into some more issues. So might have added a test like this. But remember, I then can't interact with take 1 gold coin again for exactly the same reasons as I had with dig. Yeah. So dig. Once it was called, the chest was gone. In the same way, once the coin is called, the coin is gone. So I have to declare this temporary kind of place to store. So again, as I say, because I've carefully controlled my loop bounds here, it won't really ever be the case that take 1 coin is null. But just to show it again, to show you the kind of full perspective here, I'm going to go with coin, extracted coin. That's a nice word. Take 1 gold coin. Store it in here, and then I can go ahead and do this null chest. Again, probably won't be an issue for my solution. But just to show you how this would have worked, again to re-emphasize this idea that we only call these methods that are mutators in disguise once. Okay. This makes sense so far. So we go through each location. You could actually split these into separate methods. Might be nicer. I'm going to do that. I'm going to say take this and I'm going to make my own separate method. Okay, I'm going to leave it public, but it could be private. So I'm trying to find a decent place in the course in which to talk about private methods. I might never get around to it, so actually let's do it now. So private methods allow us to, as they suggest, declare methods that can only be used inside the class. So typically they don't offer functionality from the class. They actually just offer internal support to public methods, which is why it's fine to include extra private methods as in addition to those that are used in the requested in the brief, because they just support the public methods. They just support the operation inside the class. So if they don't warrant any external interaction, and in fact, if interacting with them externally might cause an issue, then you're going to make them private. Okay, so the reason here is I'm going to say private void. Again, making these private or actually having this method at all wasn't part of the expected solution. I just want you to kind of see this in practice. So I'm going to call it something like extract coins. I'm going to take a treasure chest. Again, not part of the solution. Just want to show you this extra bit of functionality. So now I can call this chest. Let's call it treasure chest. Like this, like that. Okay. And then inside here I can just say extract coins from the treasure chest, which is quite nice, really, because now I have this flexibility. Of course, it's called dug chest. Okay, so again, private methods, actually you wouldn't want this to be public, I don't think, 'cause you wouldn't want to be able to extract coins from a treasure chest directly. You'd want to actually go through, you want to get the treasure first, so it makes sense to make these private. And of course, as I say, because we've asked for this fixed interface, it's nice just to have these methods that support the main interface. Extract coins from the chest, take 1 gold coin each time, and if it's not equal to null, again, a redundant check somewhat in my solution, but nice to have anyway. I'm going to say, so I have my coin now, don't I? I have my extracted coin ready for my use. What do I do with it? Well, the last step is to actually put it inside the pirate's purse, right? So we know we have this field purse, so we're going to say purse sum index is equal to extracted coin, right? Makes sense? In the same way that I held this extra variable last coin, yeah, I need the same process for my pirate. And this is exactly what we saw in the notes, right? So if I have this arbitrarily large array, like we're looking at user input of numbers, then I'm going to need some supplementary variable that's going to allow me to track where the next index to enter into that array is, right? Makes sense? So remember we saw this idea that if we have this big array for user input, we start this next index at 0, and then it goes 1, 2, 3, 4, 5, going up as we increment it, so we're always adding into the next free location in the array. Okay, so same process here. I'm going to say purse next int plus plus. Again, look back at the notes if that doesn't make sense. I didn't call it next int, did I? Call it next index plus plus. Again, look back in the notes. Why is this? It's just the opposite version of what we did inside treasure chest here, where we kept track of the last position and we were always taking things from the end. Here now we're just always adding things to the next free position in the array inside pirate. Which is why we have this next index plus plus. Alright. You could, if you wanted to, add an extra check to make sure that you only add coins while next index is less than, so you can say something like it and next index is less than purse.length, right? Because obviously if the index reaches 99, because it's 100 in length, no, 999, so the pirate's got lots of coins, then you wouldn't want it to the pirate to proceed, obviously. Could be in there. I'm going to leave it out now just to keep things as simple as possible, and because, again, the idea here is that they never reach this upper limit, really. Again, I would be fine for you to have that in there. I'm going to leave it out for now just for simplicity. I would be fine for that to be there, and in fact it was in the notes, so it's something that you might like to include. Obviously, just an optional little check, not something you needed to include, not something that will be included in the marking, but there we go. Okay. Right, so this is looking all right. Just confirm with yourselves what next index plus plus does if you're still confused about that. It's just, again, in the notes, we're just always adding the coin to the next free space in the array. Okay, so here what we want to do is actually, we're nearly done, I guess. So what we want to do now is actually return true after this, right? So once the chest has been obtained, which is indicated by this line here, if there's a chest, I've extracted it from dig and it's not null, then I know that I've got a chest. So once I've extracted the coins, I return true to indicate that I have successfully got treasure from the island. Otherwise, I'm going to return false. And again, try your best not to use return too much in this way, but it's okay here when there are fewer options about what to do. Okay, probably made a mistake somewhere as always, because I made the mistake that you shouldn't of not testing it in individual bits. But I'm aware time is marching on, so I'm going to say now add my next bit, which says, if I'm not mistaken, it should be possible to get the total coins in the pirate's purse. Total coins. And then we're going to return. And here's another subtlety. We don't return purse.length, right? Because that's 1,000. And that's just the maximum size. We don't want to interact with the maximum length. Again, this is what we looked at when we looked at partially filled arrays. Purse is a partially filled array, so we actually want to return next index, right? Because next index always indicates, and it's not a method, it's a field, how many coins are in the purse, right? Because if there's one coin in the purse, so it's empty to begin with, next index starts at 0 and then gets incremented to 1. Okay, so that's one item in the purse if we do this method once, ignoring the loop. Let's say we put one coin in here, we do this line at least once, and the value inside next index will be 1, so we always have the right number of coins listed there. I believe it's time for a treasure hunt. So we're going to say system.out.println. Now I'm going to add this back in because I want to know whether my hunt has been successful or not. And then we say another system.out.println. Again, probably does something wrong, but we'll see what happens. Get total coins, sorry. And let's see what happens. Okay, great. That looks right to me. So what has happened? So we have a map with 3 islands. Make our Captain Chapman. We make him look for Havana, so effectively he finds it on his map. Then we make him sail to Havana, which is effectively what Get Treasure is doing, and extract the treasure on the island. Okay, so we've given him this island object. He's gone through each of the berry locations. We know one of them because I did that. Remember, I saw that erased. I did that erased.toString before. We know that one of these locations contains the treasure chest object. So we get it out. We know it's not equal to null, so we need to do this because sometimes we know berry locations will be empty. We extract all the coins from there, and there we go. So we call extract coins. We do another loop to go through all the coins in the chest. Again, the same process of extracting and storing to avoid any issues with double access, accidental mutation. That sounds a bit creepy. If extracted coin not equal to null, so we check that we've not gone over the bounds, although that wouldn't be possible. And we add that then new object to the pirate's purse and increment in this way. That's it. That's the functionality for the pirates class. So I know lots of you found it quite tricky, but if you think about it, it's not too much going on here. It's just a couple of loops and some if statements really, and it's just about understanding the interaction with the arrays. It's not really either too long, so it's only about 70 lines here. And indeed, gold coin is, as I said, only about 9 lines if you ignore the spacing and the brackets, depending on your metric for lines. So there you go. It's working. So what happens now if the pirate goes back to that island and then we get his new total coins? See if we've got kind of something nice and good going on here. Great. So he sails to the island once. Again, this is a key part of the functionality. He sails to the island once and gets his 18 coins. Sails to the island again, of course, but now because the treasure's been removed, he still has 18 coins because the result of the hunt is false. He's been there, removed the treasure, now only got 18. So some people are asking, why do we need to check for the case in which the treasure isn't on the island if every island has a chest? Yes, every island has a chest initially, but then obviously if once that chest is removed, it doesn't anymore. Okay, good. I guess that's the bulk of the video done. So if time is marching on for you, that's that. But we'll just finish off the last bit of it. So the user input, which is nice. I think it's always nice to have a nice check of user input. So we don't just want to do these statements manually. We want to do them based upon user input, don't we? So we want to get some information from a user and use that to conduct a search. How do I get user input? Scanner. You should know this by now from the previous assignment. New scanner, system.in, in.nextLine. Actually, let's talk about that once I've imported it. So I can import like this, java.util.scanner. Remember, you're within your in your own rights to ignore this warning. We've talked about the consequences of closing a scanner and how Java's just being extra cautious here, and it might actually not want to close it, so fine to omit that. And what we're going to do is, I'm going to do the simplest form here of loop. You could do a do-while loop, and in fact, given what the notes are telling you, that would make more sense. Actually, let's do a do-while loop, why not? So we say string user input, and we say do, I'll explain this in a sec, while user input well, I'll do it not equal to, what was it done? So I had an amusing demonstration of this in my office this week where we couldn't quite work out what the stop functionality was. I think mine was done. What if I asked you to do stop? Yeah, so or exit or something like that. Okay, so that's what's going on. Say the local variable might not have been initialized, which is a good warning. So let's fill this in. I'll talk about this in a sec. Equals in.nextLine. Okay. Right, so what's going on here? So this is the do while loop. This is the exact form we've seen, well, we saw one slide on it at least inside the control flow section. What we're doing is we're relying on this idea that the user keeps entering input until they enter a certain keyword, and that keyword is stop. So and the problem is, what we could do instead is we could say equal to empty, and then we could shift our while loop round like this, and we could say this would be the same thing basically, and it would keep going. Now it would be the exact same functionality as the do while. Remember, lots of loops are interchangeable. Except, of course, with the do while, you get this initial first loop, which allows us to keep this empty. Okay, so if I try and make this empty now, it's going to complain, isn't it? Remember, because it's the risk here, and of course, obviously there's a risk because there's nothing that happens in between these two lines, that this will be empty when you try and compare it to stop, which you can't do because you can't compare nulls or empty values here to other values. Okay, so this won't be allowed. So the only solution is to do something that some people consider quite ugly or unreadable, non-readable, whatever the correct grammar is, which is the use of what we call a sentinel value. So a value that sits there, doesn't serve any purpose except to be changed in the future. And it always has to differ from this condition. So this is a way of emulating one run of the loop. That makes sense? So you create this empty variable, and then you can test it, and it has to be different from the equals, because otherwise what you're checking for in the equals, if this was equal to stop, then obviously the loop would never run. So it has to be something different, typically an empty string. And then you use this to get one first run of your loop so you can get your actual user input later on. We can avoid this with the do while. Again, don't mind if you did or didn't use a do while here, because they're, it's do whiles, I think, even though they are not exactly the same semantically, they are again verging on a style choice. And then you do the same thing with the next line here. Okay. Note the use of next line. Lots of people were saying I have a space in my input. How do I deal with that? We did a lecture exercise on this. We looked at the use of next line, and also given that I've showed you the scanner class and showed you how to approach documentation of classes now, it's not unreasonable for me to ask you to kind of figure this out on your own as a little extra exercise in the assignment. Same for obviously the math class with random, or indeed the random class itself. Now that we know how to use the documentation, it's not I don't think unreasonable to ask you to kind of look these things up, but in this case this was actually in the slides as well. So you would need next line here if you had a space in one of your islands. And I think maybe it's just good practice to have it as well, but obviously if you didn't have a space then you wouldn't have to do that. That's not a case of those who did have spaces in their islands having to do more work. It's just a case of different solutions because we try and, as best we can, make your assignments unique. So whether you need to use next or next line here, I think there's equal amounts of work involved in working out what the best method to use is, so there's no difference there in the assignments. But of course, if you did have that space, you would definitely have to have next line in there, whereas vice versa would be fine still. Okay, so this grabs the next line from the user. I know some of you are having some issues with this. All right, so that's going to grab the next line from the user. And then what do we want to do? Well, we want to go back and do those functions that we had before, right? We want to make our pirate search for whatever's been input, right? So we could say, again, we can kind of replicate this. We can say get name. So we could say system.out.println. This is our pirate searching for the islands. We run it, and now it's waiting for inputs. If I say Havana, it's going to say Havana, right? Remember we were doing this test before where we were testing, is the thing that we import found? If it is, we're going to get a name. Make sense? If it's not, then I do United Kingdom, and I get this null pointer exception. How do I handle this null pointer exception? Well, again, I'm going to actually have to test my result before using it, aren't I? I'm going to have to say, is what I've returned equal to not equal to null? Only if it's not equal to null can I interact with it. Very same principle inside, similar principle inside Pirate with the extracted coin, checking that it's not equal to null before putting it somewhere or doing something with it. The same for the dug chest as well, despite the terrible grammar. Okay, so I'm going to have to say if pirate search not equal to null, and I can go ahead and then do this method, can't I? I can then say, well, what's the name of that island? That makes sense. So here, remember, search doesn't have an effect. It's not a secret accessor in disguise. So if we look inside Pirate, search doesn't change anything. It just gives us something back. It couldn't change anything because it's a for each loop. So here what I want to do is I want to protect myself from the null returns from search, because obviously if this is null, the result of this this should be an island object, but if the result is null in the negative case, I can't call get name on null. It's not possible. So I first test that and then go ahead and work in this way. Okay, so again, this assignment was just about interacting with null, which was covered in the lecture prior to its release. So Havana, fine. United Kingdom, nothing. Make sense? Okay, so now I have another chance to enter Havana, and it's all good. Alright, so I'm protecting myself here against the null values. And I actually want to say something. I don't know. I want to let the user know that what's going on and what the state of the program is. And to do this, we needed this final method, didn't we? We needed this method speak. So we wanted something like public void speak. Okay, it doesn't do anything except take a string, a phrase to speak through, and there were a certain number of phrases that you were asked to include. So you could say. Again, I'm going through this quite quickly because we've looked at this already and how to do all these things. And indeed, in the assignment, this should have been quite quick and straightforward. Given that you were well practiced in arrays by then, we could say phrases equals new string like this. Oh, no, sorry, you don't do that. You say, just put your phrases in like this. You say, I'm only going to do 2 of them because I know you're all cringing at them anyway. Shiver me timbers, like this. Okay. Again, single line initialization works for works for sort of string or semi-primitive types like string as well. And then the process is simple. Again, all stuff we've seen, just giving you that last little exercise to kind of cement your understanding. And what we want to do is we want to take the phrase and we want to add phrases, and the value that we want to do is math.random multiplied by phrases.length, and then all cast to an integer. Okay, if any of this doesn't make sense, everything in this method I've talked about already in the video. I've talked about creating single line array declarations, did this inside Treasure Hunt for my island. I've talked about the use of random here and how this works. I multiply it by the length of the array because int always gives me an upper bound that's one less, and the upper bound starts at 0, which is perfect. It's the exact functionality that I want. And speak here, all it really does is takes a string and adds the phrase to the end of it. So what it is, it's a wrapper around, it's a wrapper method around this print line statement that adds something to it. And wrapper methods like this allow us to do something else, to test another little final element of our knowledge, which is the use of static methods, right? So remember, our rule is that static methods, or methods can be static if they don't interact with any element of the class's state. Right, so search, so remember, again, go to the other static video and have a look at this. Remember, we looked at how search, how to identify a static method, sorry. So search does interact with fields, so it can't be static. Get treasure does interact with fields, so it can't be static at least, or extract coins does. So obviously, if this were to be static, extract coins would have to be static. And that can't be because it interacts with purse, so you have to look again at these dependencies and how that affects the use of static. Total coins obviously can't be, but speak can, right? Because speak doesn't interact with any element of a pirate's state. So a few fun arguments here about what constitutes pirate language and whether this is the right idea. People saying, well, pirates might speak differently. I like the wonderful discussions that arise as a result of these assignments. The idea here is, so on a practical level, it makes sense, right? Because you don't interact with any element of pirate state, because all pirates speak the same. That's the idea, and this is the actual fact, right? So, or what we're conveying in this assignment is pirate language, so that the language that they speak is the same. So they might use different words, but we're reflecting that their vocabulary, their vocabulary, the words that they have to use are the same. Okay, so they might put those words together in different ways, but overall they speak with the same language, and that's what we're reflecting in this assignment with the speak method, with these little phrases that you add to the end. Okay, so in the same way that you and I speak English, but we do so using different words in different ways, we're still speaking English. So it makes sense conceptually for speak to be a component of the class, because all pirates, we're saying here, speak in the same way, which makes sense. They share a common pirate language, albeit a very, very simple one that's basically a permutation of English. But it's not the idea that we can still, although we're not directly capturing it in our program, we're not saying that pirates, always say the same words. That makes sense. So it's the pirate that does the speaking here. I was happy for this not to be static, no marks lost here, as I said on the forum. Again, if you did go down the conceptual understanding that pirates did speak differently, you could choose to leave static off on here. Again, style choice. That would be fine. But I'm going to leave it on there just for practice, just so we can really look at what how using a static method means. All right, so I want to say something like pirate.speak, enter island name, so we know what's going on. Like that, don't I? Okay, note how I access it here through pirate, right? Because again, it's a static method. We're not saying that this is a pirate speaking, this actual pirate here, or Captain Chapman. We're not saying this is Captain Chapman speaking. We're saying this is being said in the pirate vernacular. Does that make sense? So it's not necessarily in that way. So it doesn't actually say that the pirate necessarily, in the brief, it doesn't say that the pirate announces different things. At least I don't think it does. So it just says it should be printed. That should be printed. You know what I mean? So it's not the pirate announcing these things. If you took it under your interpretation of the assignment that it was the pirate saying things, absolutely fine. But that's not the interpretation I was going for. But again, that's the interpretation. It's fine. Just so long as if you did use a static method, you access the method statically, not through the object. It would be awkward to do pirate.speak. Indeed, you'd get a warning. So it should be through the class. If you want to leave the static off though, then of course it would be pirate.speak, and you could take static off here like this, and the warning would go away. We could ignore that one on in for the reasons described. Okay, I'm going to leave it static. So enter your island, take that island from the user, If it's not equal to null, then we've got the island to search for. So now we can go ahead and do what we did before, which is pass the result to get treasure. Okay, so we say get treasure. And what we can actually do is wrap this in an if statement, because we know this is going to return true or false. What am I doing here? Too many. Have I spelled something wrong? Get treasure, pirate.search.getName. Pirate.getTreasure. Have I been spelling something wrong the whole time? Get treasure. Oh, of course, 'cause it's not get name, is it? Because that will return a string. So we actually just want to return an island. And there we go. Okay, so we say, we know that because we've done pirate.search user input, we know that's not null, which means this must correspond to a legitimate island. We know we can take that legitimate island object and pass it to get treasure. These are the same things here. So get treasure is now given an island, so that's the functionality we want, and then we know that get treasure, the method can just happily go off, explore the island, take the coins, and update the pirate's purse. Okay, so then we can say something like pirate.speak found treasure on, we could do anything, we could say user input maybe, and then we could say pirate.speak new coins in purse, and then we say pirate.total coins, and there we go. Else we could say pirate.speak no treasure found on user input, like this. And of course we could say pirate.speak no island found with name plus island user input. Alright, so again, if you want to refresh yourself with the do while syntax, go back to the notes, but here the first thing that happens around our loop is we ask the user to enter island name. They do. We test that name. If it's null because they've entered something like UK that doesn't exist, like we did down here, then it says no island found with name. If it's not null, then we know it's a valid island, so we try and then go into this nested if to see, well, can we get treasure from that island? Is there still a treasure chest there? Because it might have been already taken. If it is, we say we found the treasure, we get the new coins in purse. Otherwise, we say no treasure found. Okay, let's try it out. Let's see what we get. You see I'm getting my my nice pirate syntax here, which is going to shows that the static method there is working nicely. So I could say Havana, okay, go back to Havana, no treasure found, perfect, because the chest has already gone, so we don't say anything about the coins, but we know hopefully they're still on 18, and then we go to Nassau like this, found treasure on Nassau, and we've now got the 18 more coins, if my maths is correct. And then back to Nassau again, and no treasure found. Right, so it's working exactly as we want it to, which is great. Okay, good. There are a couple of optimizations you could do here. So you could, if you see if we run it now, and we enter stop, we still get no island found with name, stop, which isn't particularly readable. So what you could do is put an if statement around here. So you could say user input equals stop. Only then would you proceed with the remainder of the printing. That'd be great. That's fine. Just a nice little touch there in the work. So we say that if it's equal to stop, then obviously it just ends. That's good as well. That's nice. It might be better to have a lowercase s there. Inside Pirate, when we're doing the comparison, we could say something like equals ignore case. This just popped into my head. If you wanted to, we saw this last time, or equals. Remember we had this two lowercase thing. Makes sense. So that would allow us to ignore whether they did up or a lowercase. Actually, let's leave that in. So I'd say go if you want to see any more details of this kind of user input stuff, which we looked at in real detail, or you want to see it in real detail, I would go back to the assignment 5 solution. Okay, so that's it. As always, there's little optimizations, little things you can improve on, but that's the general bulk of the assignment done. Let me just re-emphasize some points here. So, yeah, most difficult assignment in PPA, brilliant. So impressed if you've made it through the assignment and also made it through this video. Very, very impressed. Well done for all your efforts. I know you've got a lot going on, so thank you for dedicating the time to this. I promise you it'll be worth it in the long run for all this experience that you're getting. And of course, just if you're able to do as much of the assignment as you can, that's fine. I know there are concerns about grades, but don't worry. The marker is strict. We're less strict. Everyone will get the correct grade that represents the effort that they've put in, I promise you. Okay, so a difficult assignment, don't hate us. We're not trying to torture you. We're trying to give you the minimum amount of work that we can to help you through and learn effectively. And remember, of course, these videos are your feedback. The grades are not your feedback. It would be very bad of us if they were. They're not. We work very hard to separate the two. You get this is immediate feedback, and hopefully you can see just how rich I try and make it. So this is immediate feedback. You get personalized feedback from your TA. Please capitalize on this. Please look at the stuff that's going on and see where does it radically depart from what I'm doing now. And if you don't agree or you want to query, what's going on, why is it different? Talk to us. It's so much easier to have a discussion with someone on feedback if they've kind of taken some points from the video already and want to discuss them. Definitely, all right? But overall, please now. I really hope it's not. It won't be too late. It's fine. Watch these videos. Use them to improve. They'll keep coming throughout this and the rest of this semester and next semester as well. Okay, thank you very much.